Hey everyone, welcome to the live stream. I hope you're having a good day. And this is another live stream about the Securinets. Okay, the Securinets Friendly CTF. It's going to be a reverse engineering one. I also got a new microphone, so please let me know if the sound is not that good. Okay, so also the quals have terminated this weekend, and congrats for the qualifying teams. And yeah, we got the author of the reverse engineering challenges on the live stream. Shout out to Jihad Qadis, and he's going to help me manage the challenges. Crispy voice. I don't know what you mean by crispy voice, because I didn't hear it, but we could remove it if it's not good. The voice is perfect. Then your hearing is not good. The sound is sounding. Yeah, good. Okay, so the views count is actually low, but that's not a problem. It will get higher. We could start. Sorry for everyone joining the live stream late. Maybe people thought that it's going to be on 8 p.m. and it's actually 7:30 p.m. I actually need some air into my room, and yeah, so welcome everyone. Your ears are vibrating. So yeah, before actually doing the challenges, I'm going to talk a little bit about what reverse engineering is actually about. And we could then start solving the challenges from the easiest challenge to the, I don't know, to also another easy challenge, but just slightly harder. Okay, so I just forgot to open my Windows virtual machine because I got IDA there, and yeah, I actually need more viewers. Then I could I feel I could start talking. I'm not sure if I could start right now. Yeah, brute force. Yeah, we might brute force a lot on this one. Strings. Yeah, strings is always the key. Don't be a noob. Use strings. I also need my... Okay, shit. I need to switch profiles from here. Okay, what a good day. I don't know how to use Chrome. Okay. Yeah, it seems like I need to actually... Okay, there's no problem. I could do that. And I could start Chrome. And I want my profile. And then I could have another guest profile. Where's the guest profile? Yeah, so I could have this one here. I was just going to access my channel to take a look from time to time. And yeah, so I think I'm going to start because we don't need the live stream to be boring and time consuming. So yeah, let's start the show. All right. So for those who are new to the concept of reverse engineering, also I just wanted to see what this link is. Okay, it's my link. I don't know what you are doing. Yeah, share the live. Yeah, that I would be thankful for sharing the live stream. So, okay. Okay. So, the camera is on the bottom, on the top, right? So I don't make mistakes again. And yeah, let's talk about what REV is, or reverse engineering is, basically. So, reverse engineering is actually about a lot of things. And reverse engineering is not something that you actually... Yeah, thank you for sharing, everyone. Reverse engineering is not something that you would actually teach, because yeah, it's basically you get experience by actually practicing a lot, and then you start playing, whether doing reverse engineering your way on your own style. But the things that could be taught on reverse engineering are tips for reverse engineering, the tooling, and basic computer stuff, and maybe some Yeah, I forgot what I was to say. Uh, yeah, just tooling tips. And what else? What could we teach else? Yeah, I think that's it. I don't know. I just feel it that way. At least I have just experienced it that way. And I've been doing reverse engineering for a long while now, and it's actually a very cool thing to do. What are task word application of reverse engineering? So yeah, this is a good question that everyone should be actually asking themselves, answering them. I don't know what to say. What is the use of reverse engineering in the real world? Well, basically, we're gonna talk about real world mostly, and reverse engineering in a real world context, it actually involves cracking. It actually involves game hacking. Mostly these like two categories, but you could actually mod stuff, like add mods. I don't know what else to see. And also, yeah, for sure, we got the malware analysis, also malware development, because you need to know what's actually going on in order to make malware before even reversing it. So like this is mostly what real world uses are for reverse engineering. And yeah, basically cracking is just about malware analysis. What about malware? Yeah, I've added malware analysis. So cracking is actually about let's say you got some program that will it just wants some serial key, right? It wants some serial key, and you don't want to buy the serial key. You don't want to buy a license. What are you going to do? You're just going to patch the program or crack it in a more general way. So yeah, so you're gonna have access to that pro version of the program, let's say, for free by cracking it. Game hacking is involves actually creating mods for the games. It actually involves what else does it? Yeah, it actually involves also bypassing the anti-cheats, because sometimes a game would have anti-cheats, and so yeah, you might want to bypass them. You actually might crack games, and so on and so forth. And for malware analysis, everyone should be familiar with what malware analysis is. It's basically analyzing the behavior of some malware, reverse engineering it, trying to know what bad things it's going to do, or it's trying to do at least, and and so on and so forth. There are many things to do in this section. Yeah, for malware development, you should actually know reverse engineering in order to make malware development, because it involves also so much testing. Will AI take our jobs as reverse engineers? Yeah, you could actually try to pass these challenges to ChatGPT, and you will get an answer. My answer for this is a big no. I would say a big no, because you know why? Reverse engineering techniques, or at least anti-reverse engineering techniques, which make it hard for reverse engineers, is it's always evolving, and you always get new techniques every day and new ideas. So it's hard for AI to actually keep up and manage all this news. So on the other hand, let me just try to define this in a general way. So reverse engineering is basically you are trying to understand how stuff works, basically. And this means that you might actually understand the internal behavior of an application, a program, or also a system, a whole system. And what I mean by a system is basically, it might be a computer, it might be just some hardware circuits, and yeah, it might be anything, basically. So this is what it's mostly about. So yeah, what we're going to do today is basically play the basic reverse engineering challenges, and we will try to get familiar with some tooling, some tools, and I will explain why we are using tools. And we are going to also try to understand how most of the applications work, and what do they want. They might be about cracking, they might be about well, I don't think modding is here, game hacking wasn't here, but I saw some malware category, so maybe this is also a thing to do. Anyways, so I think I would start actually doing the challenges, and like along the way I will explain any stuff that we encounter. So yeah. Alright, so we got the repository here. I would share a link for everyone interested in trying the challenges themselves. And also, I can't actually do all the challenges in just one live stream. This is impossible. We can do that. So yeah, it's going to be 2 parts. By the way, is Bakshish animation configured for this live? It should be configured. Yeah, I've tested it actually before the live stream because of the last time mistake. I also changed the placement of it. So yeah, it should be working. Yeah, this is it. All right. Okay, so I think the first challenge would be the welcome, the second challenge would be the welcome again, and then we are going to try and figure out what the third challenge is, because sadly the website is actually down. They took down the website because yeah, it's costing them so much money, and yeah, they need to actually take it down and take all the instances down. But yeah, we have the challenges, we could solve them locally. And also just one question for the author. There is no C. Yeah, there should be no C source code. I mean, it's reverse engineering. Like, come on. You just have a binary. Like, you just got the executable, and you need to make. Okay. تستيلنا كالبخشيش بالله. والله نجم انت تستيلك. I could test it just a second. Just give me a second. They also fixed my picture, so yeah, good news. Okay, you could actually make tests for stream alerts. Like, I could make a donation here by testing, and yeah, it works, as you could see. So yeah, totally working. Okay, let me also make this here. And if I'm lagging or something, please tell me. And yeah, so let's get back. So we got the first challenge. It's just called welcome. We got this binary. Sadly, we don't have descriptions, but yeah, this is a good opportunity to actually try stuff blindly. It's a good way. I see. I don't know. I think it's a very good way to approach the challenges without descriptions. So yeah, we have just the names of the challenges, and we got the binaries. I'm going to download the first binary. Wait a second. That's not the thing I wanted. So this is the first challenge. It's called welcome. So we could run the file command on this binary, on this file, and it's telling us that this is just an elf. An elf is just an executable on the Linux system. And yeah, so we don't care about like all of the information for the moment. I'm going to talk more about it when needed. So let me also zoom in the terminal. So the first step is to make this executable, because this is sadly not executable. You could see the permissions in here. We only got read and write permissions, and we don't have permissions to execute the file. So we need to change the mode +X, which makes the file executable. Now we could execute it by entering a dot, a slash, and just the file name. So we're gonna write the file name there. And yeah, the challenge got launched, and it doesn't seem to do anything. It's just printing out some like fancy menu. And yeah, there's nothing special. So what are we going to do here? So now what we are currently doing, and the way we are going to solve the challenge, is through something called dynamic analysis. So let me explain this in a real quick way. So in reverse engineering, we actually got two main like approaches to do, and you could make a mix of them. So the first one is just the static analysis, and the second approach is actually the dynamic analysis. And I have talked about this in like times before. So this would involve only like reading code. So you, in this section, you are only trying to read the code of the program, and from like by reading the code, you need to understand how the program is actually working like internally. All right. On the other hand, dynamic analysis wouldn't actually involve this. So this doesn't exist in dynamic analysis. You don't read code. You're not going to read code, at least like at the beginning of the analysis. Then like what you are doing most of the times is just executing the program, well, let's say like in a more general way, interacting with the program actually. You are just interacting with the program, you are executing the program, you are giving the program some input, getting some output, trying to understand the behavior from only giving it output, inputs and outputs. And I could give you an example about this. Let's imagine like some application that once run, like let's call the application program. So you run this, it will ask for some inputs like input X and input Y, and it will return 2, let's say, after you input a 1 and a 2, and a 1. So from like executing the program, entering 1, 1, and getting the 2 as the output, you understand that this is actually most likely it's doing addition. So it's just doing addition. All right. So like from like interacting with the program, you understand what the program could be doing, because nothing is sure. You are not really sure of what you are saying until you actually take a look at the code and verify that. But yeah, it's as I always say, it's good to make assumptions when reverse engineering binaries, because that would be also helpful when you are going to take a look at the code. So like, because when you make assumptions, you are trying to imagine how the program works internally, right? And by creating this this image of the program in your mind, when reading the code, you will make connections between what you have imagined and what you are seeing on the screen, like the lines of code. So it's actually a very good approach to do. You need to make it a habit, basically. You just need to make it a habit by time. I wasn't doing that at the beginning when I started reverse engineering, but after I started doing this technique, it actually became a habit, and like it's really helpful. Sometimes it wins you time, sometimes it might lose you time, but yeah, it's always helpful. So from interacting with the program, you could do debugging. You could just do this thing, and you could also do tracing, and I will explain tracing in a second, or maybe I will explain tracing later because I think we will encounter it. Hey everyone, well, welcome to the stream. We could do tracing, and what else could we actually do? Well, there are so many techniques. There are so many techniques, literally so many techniques. So I can't really remember them all right now, but mainly you would interact with the program, try to debug it, try to trace it. Maybe you could do also emulation. So you could emulate some parts of the code. Like let's say there is like some int add. Well, int x, you don't know what the function is actually doing. It's taking 2 arguments, a and b as integers, and it's going to add them. So it will return the addition of them. You still don't know, and let's say like this code is actually so ugly, so it's obfuscated, you can't really read it. And there's the main function, is just calling the x function with some inputs. So with emulation, you could just emulate this part of the code, give it arguments to the function, and like get so many outputs. You could give a list of inputs and map it to a list of like output results, and then you could just try to understand from the inputs and outputs what the program is actually doing. So yeah, there's actually so many ways to do this, and yeah, it depends on what you like. It depends on like how you actually think of stuff, because yeah, everybody is special and got some way of creating patterns in his mind. And yeah, so now we are doing this. We are doing dynamic analysis. We interacted with the program returned nothing. Okay, so there's actually a good tool that I always tell people to say, and this is a joke. It's called strings, all right? It's called strings. Brute force. It's called strings. So strings, what strings is going to do? It will return all the printable strings from the program, all right? Because you know, when the program gets compiled, this is a compiled code, this is compiled stuff, all right? So it contains machine code, and it contains so many garbage data. If you try to cat it, cat command will just read the content of a file, you will get actually so many garbage on the screen, and you could see this in here, right? So running strings is a cool thing, because strings will only return the printable stuff, like in a good way, like in a way you could read, because this is better than just cutting the file and trying to figure out which are the printable characters and like separating it from the garbage just by looking at it. On the other hand, strings will actually make stuff clear for you. It will print every string on a line, and yeah, you got something. And look at this line. We got a funny thing in here. We got the flag. Oh yeah, this is a way to solve the challenge, the first challenge at least. So like the flag was probably defined somewhere in code, and it was defined in plain text. Running strings, we return all the strings that are in the binary. One of the strings was the flag. So this is a good way to brute force is not allowed. This is a good way to like gather information, because there is actually some information gathering that you might want to do from time to time before trying to read the code. So strings will give you a general idea of what the program is doing. And let me explain this more. Like, apart from the flag, the program is using two functions. It's using puts and putCar, which will just output characters to the screen. All right. So you know that the program is like got some output mechanism. It's outputting stuff. You could see also like it's using, well, there is actually no other functions. It's only using the puts and putCar. But yeah, you might get like a function name like a crypto thing, like an MD5 or I don't know, AES or RSA. And yeah, from just running the strings and getting that function name, the cryptographic function name, you actually would know that the program is trying to encrypt your data using a way or another at least. So yeah. Okay, so this is the first challenge. Strings is enough for this one. I will also create folders for. Oh yeah. Sorry. I will create folders for the challenges. So if we need something to send in the chat or to get back to it, we will try to get back to this easily. So yeah. Welcome to this stream. So the second challenge should be the welcome again, and this is the binary. I'm not going to take a look at the C code. Also, this is the first time I'm trying the challenges, so I got actually zero idea about them. I don't know. Welcome again. Welcome again. Oh, wait a second. Welcome again. So let's download this one. And as usual. Yeah, really, welcome. Okay, so yeah, this time it's not just outputting the menu, it's actually asking for it's actually asking for the flag. And if we try to input random data, it will tell us that yeah, our data is wrong. So yeah, guess what? Let's run strings. Let's gather some information. Oh yeah, there is no flag. Good job. Good job on this one. So yeah, probably the flag was stored in some encoded way and it's being decoded at runtime, or maybe this is even simpler and we are not getting the flag. So before actually doing anything, I'm going to do tracing. So let me explain what tracing is quickly. So tracing, what is tracing? All right, this is not debugging. Please do not confuse it, because so many people do. Okay, so tracing would just like it will output stuff. It would just output what the program is doing currently. For example, let's say we got this program. We got like the main function. The main function is calling the printf function with some string, and it's like taking your input, let's say taking some input, storing it at a variable. I can do the end, so yeah, like there's an end in here, or let's say it's a string. I don't care. Yeah, it's a string. So when tracing this program, like after compiling it and executing it, when tracing the program, what the tracer would actually return, it will return the library function calls, for example. It will tell us that main is called, alright, the main function was called. It will tell us that the printf was called, and it's using argument like arg1, the first argument of the printf is just AAA. Okay, and it will give us like the return, like what the printf returned. Okay, like let's say it returned 3 because we outputted 3 characters. Then it will tell us that scanf is being executed. It's taking as an arg1 the percentages, and it's taking as an arg2 like some address in memory, alright? Because this is an address in memory where our input would be stored. And yeah, this is tracing in like a general way. Tracing would just give you what the current program is doing in like a very high level inspectation. So it will just tell you what the program is currently executing as a function, and it will tell you what parameters the function is taking and the return, like the returning result from that function. And when I try this one, you'd like it will make this clear. So yeah, this is the challenge. I'm going to run some program called ltrace. So ltrace, what is ltrace? Ltrace is just a library called tracer. So when doing calls to printf, scanf, fgets, or like whatever, all of these are just library functions. They are not user-defined functions. So what ltrace is going to do, ltrace is just library trace. It will only give you what the program is currently executing from the library functions only. It will just give you the library functions only. And let's try it. And we got some questions, but I will answer it in a second. So yeah, let's try this one. Okay, it didn't execute. Good day. It's a very good day. There is no problem. There's no problem with this. I also think like I got some problem with the strace, because I remember this is not the first time this is happening to me. Yeah, I don't know though why this is happening. Maybe I need to reinstall it, but this is really sad. The question was, what is the difference between strace and ltrace? As you know, there is like the current program that I was trying to use called ltrace. There is also something called strace. So this one is used for library functions like library tracing. This is on the other hand used for system call tracing. Okay, so what is a system call? Well, a system call is just the interface to execute stuff like from the user land. There's some user land and there's the kernel land. So the kernel is just the heart of your like operating system basically. So when the user tries to make something, let's say the user is trying to write to some file, something called a system call would actually be requested. So a system call would happen, and a system call is identified by a number. So let's say, for example, when he tries to write to the file, the write got a number 1, so it's going to give us number 1, and it actually takes arguments too, just like functions. And this request will be passed to the kernel. The kernel will actually allocate the space on the hard disk, let's say, and it will write data to your file. The strace would tell us what system calls are being executed when the program is running. So like it will tell us that a write system call was done. It will give us the number of the system call, and it will give us also the arguments for that system call. And I could try it for this one. Oh, there's a ptrace. Good day. So yeah, cannot find. Okay, yeah, I made a mistake. Sorry. So yeah, as you could see, strace, after executing strace on the program, it told us that execv system call was executed. The execv is going to only execute the program. And then there was some opens, like this will open the link, the loader, sorry, which will link library functions to our program. It's opening the library that got the functions. It's trying to read from it. It's like allocating space in memory. It's doing so many things. There are so many system calls that happen during like the execution of the program, like the runtime of the program. But yeah, it will not tell us because there is no system call to compare stuff. So yeah, it's not telling us what our input is being compared to. So I hope I have answered the question there. Okay, yeah, ltrace wouldn't work sadly, but also ptrace wouldn't kill the ltrace. Ptrace would only work on debuggers. It wouldn't detect tracers, from what I know, at least. So there's no problem. Strings didn't give us a thing. Maybe this is the first. Also, I think the problem is from my ltrace actually. If I had another system, I'm sure it might have worked. Maybe there are arguments I might have, like I might want to pass for this to work. Maybe not. Maybe I just need to install another version or like anything. I'm not really sure. Debug, enable debugging, cdh. I don't know. Like let's try it with the d. Yeah, it's not. It requires some octal. Yeah, this is dumb. I don't want to try that actually. So ltrace is broken on my side. That's not a problem. That's not a problem. So yeah, this is my Windows virtual machine. I'm using this for reverse engineering and malware analysis and like all the good stuff. You could see I got Safari on a Windows here, like yeah, good stuff. So I'm going to actually get my IDA. For anyone who wants the IDA Pro, like the version I'm using, you could DM me and I will send you a link for the IDA Pro. And yeah, let's create some folder here for my challenges. I'm just going to call it YT. Then all what I have to do is either like re-download the challenge or just copy paste this between the systems. Okay, yeah, you cannot do that, but you could just copy it on the main operating system and then you could take it to the virtual machine. Yeah, it's there, but IDA is not showing all the extensions, so I could do all the files, and yeah, my file is there. I could open this. By the way, IDA free is good enough. Yeah, also you could use IDA free, but yeah, if you are advancing and getting better, you need like a better decompiler and a better debugger, and like you need to enhance your tooling basically. So my IDA hangs a bit. Yeah, it actually decompiled my stuff. Oh, there is no main function. There is like IDA detected this, but I think there is no main function. The flag was also there, but yeah, as I thought, you were just trying to copy it as chunks. I think this is why it wasn't. Yeah, it wasn't detected. And yeah, there is no, like I was thinking I will get an strcmp, which is a function that compares two strings, like a library function. This is why I thought maybe ltrace would work, but sadly it wouldn't even work. But yeah, the flag is in here. The flag is just in here, defined there. But yeah, look at this one here. It got UTF-16 LE encoding. It's not a UTF-8. It's not a UTF-8. It's not Unicode 8. It's not like in the usual encoding scheme of the characters. This is why strings didn't detect it. However, I think there is a workaround, because I remember doing this like before. You could actually, from the help menu of the strings, change the encoding. As you could see, strings -e, and I want to pass it. Is this L for, yeah, you get the flag this way using the L. The L is just going to, sorry, I forgot this. I forgot to try this. I'm really sorry. But yeah, thank you so much for the cool comments. So yeah, I just looked at the help menu from the tool, and in the encoding menu there was some option that will parse 16-bit Unicodes, and the flag was encoded in UTF-16, so yeah, it just appeared. So this is another way to get the flag, apart from like using a decompiler. So, and let me just mention one thing, that since this is like a simple case, a simple binary, there is something called, sorry, so there is, the binary was flagged as stripped. It was stripped, you see. This means that there are no symbols. So what are symbols basically? New strings trick. Symbols are like, I would make it in a general way, like a general way. I'm not going to enter into the details. Yeah, I could try a hex dump, but just a second. Symbols are just global variable names, and it's just about function names too. All right. So you got these two main things in the symbols in a general way. So when the binary is stripped, those symbols are gonna be removed. All right. So it's gonna remove the symbols. That means that the main function will actually lose its name, and it's just an address in memory. It's no more like, it got no more like a name, but it got an address. And there is no problem with this because the compiler will do like all the addressing and stuff. So yeah, it's not really a bug or something. Like, you shouldn't think about it that way, because at the end of the day, everything is just addresses, and the processor is reading, writing through these addresses. So yeah, it doesn't understand names like at the end, so it's not a big deal. So when it's being stripped, there is a huge problem. All right. Because the main function wasn't there. Actually, my IDA renamed the main function for me. But let's say this wasn't named. It was some sub address, like sub, because the name. Oh, it's really okay. Yeah, it did everything for me. So this is the main function. Let's say it's called sub something. Sub means like subroutine. You could call functions as like you could mention functions as subroutines. They could be called subroutines. and this is just like the offset of the function in the file. So yeah, so let's say it didn't get a name. There is actually a function that is going to execute before the main function. So this is the menu of the defined function of the program. You could see a function like these are just library functions. We don't care about them. These are the program functions that we care about, at least. And there is something called start. And this subroutine is actually going to execute before the main function. It's actually going to prepare the right environment for the program to run and everything. So yeah, you got this. The start function will always, like at least most of the cases, it will call something called the libc start main. This is a function in the library. It will it always takes as its first argument the main address function. So yeah, main address. So when you go to the start function, you will get the main function address in its first argument, and this way you could identify the main function. All right, so you could just click on it. This is the main function. And okay, I got the challenge. Let me just, for example, try Ghidra. Okay, so running Ghidra on the challenge, Ghidra wouldn't identify the main function, at least from the old versions, because this is a new version. I am not sure. It might be actually, it might detect it. So let me try and see. It's just in the downloads. I could just welcome again. Yes, I didn't open Ghidra for a long while, so it's just analyzing the program now. We could just launch. Yeah, even Ghidra hangs. So yeah, this will ask you if you want to analyze the program or not. You need to analyze the program, because analysis will try to make references to the global variables and like give you a better. It will also make the decompilation. So without analyzing this, you would never get a decompilation. You will only get the assembly code. So we could just analyze this, and it will take just a little time since the binary isn't really that heavy. And you could see this is the start on the IDA. It's start in IDA, it's called entry in Ghidra. So it's calling the libc start main, and as I told you, the first argument is just the main address, the main function address. So we lost symbols, we don't have function names, we don't have any of the function names, but we know this is the main function. So this is a way to identify the main function. We could then rename it to a main, so I could enter a new name for the function, and yeah, I know this is my main function. Also, you could see Ghidra decompilation is most of the times shit. So this is why I use IDA. IDA got actually a better decompiler, but Ghidra's got better plugins when doing other jobs, and you will know this when you encounter one. So all right, like yeah, IDA would provide a very clean output. So let's fulfill the request of our friend Jihad and make run xxd on this. So xxd will just do a hex dump of the program, so it will output every character in the program. And as you could see, this is the flag again. Let me just get up. So this is the flag, and as you could see, it's UTF-16. Oh, I can't write here. It's maybe use another color. So it's UTF-16, and UTF-16 is like 2 bytes. So this is why you get the S and null byte, the E and null byte, and so on and so forth. And yeah, that Unicode is just used for special characters. There are special characters that are defined in UTF-16. You might Google on this. And yeah, so you could do a hex dump. You could just try the strings again, because yeah, strings output is simpler than the XXD output. So you could try all of the encodings at the end. So you could try the 8-bit, the L, or the big L for 32 bits. عندي أنا البادج متاعو عندي أنا Unicode, and yeah, this is all. You could even specify like how it should treat UTF-8. So strings offers a lot of stuff. You just need to read about it. So فما كافيين هالأربعة ماني بعد غدوة فما كافيين بعد غدوة إن شاء الله. And thank you so much for the donation. Strings is OP. Yeah, strings is really OP. Strings is the best. Strings is the best tool created in reverse engineering. It's better than IDA Pro. So yeah. Okay. Let's move to the next challenge. And I hope now. Okay, I don't know what the next challenge is like in the order of difficulty. I actually have no idea. Maybe Jihad could give me the names, or I'm going to guess myself, like to just pick a challenge myself. All right. Oh yeah, let's go for assembly. Let's go for the assembly challenges, and that's a good opportunity to explain assembly and stuff. Strings for the win. All right. Let me take the 2 assembly challenges. So let's talk about assembly. What is assembly? How to approach assembly? Like how to read assembly? Well, maybe yeah. We'll see. So what we got is just this file. I think right? Yeah, you only get this file in the attachment from what I know. I posted a screenshot. Where is the screenshot? Is it on Discord or it's just... I will open Vim because Vim got actually a highlighter for assembly files. So I'm going to make one like test.asm and put assembly there. Check the last stream. Okay, let me just copy the assembly code, and yeah, let's talk. What is assembly? What the fuck is this thing? All right. Sadly, you cannot zoom in. Okay, this is a pswap. He used the pswap. All right, he used the pswap. Okay, we will explain everything. There is nothing special. So, what is assembly? What the fuck is assembly? Assembly is okay, let's first, before talking about assembly, let's talk about what is a high-level code and what is a low-level thing. So, when talking about high-level stuff, high-level is just it's just like a very general representation of what the computer is doing, like general representation of what the computer is doing. All right, this is what high level is. Low level, on the other hand, will give you details about the computer will actually do or is doing. Like both works. So when, like for example, Python is a high level function. Python, like programming language, I mean. So for example, Python is a high level programming language because you are not actually telling the computer to allocate memory or to deallocate memory or telling it like in what memory place, or like giving it an address and telling it to write there. You cannot do that on Python. Python is just a general representation of what the computer is doing. On the other hand, when talking about low-level programming languages, we got the C, and eventually a lower-level language is the assembly language. Okay, so in C programming, you could actually manipulate memory. You are doing the allocations. You are doing everything yourself. Python is doing allocations for you, and it's like it got a garbage collector that will like deallocate the unused memory. It's always doing stuff for you. On the other hand, as like on C programming, you are actually doing every step by yourself. And we got even a lower level programming language, or like a representation of code, and it's called assembly. And assembly is like giving you what like what in detail what the processor is actually executing. All right, it like in detail it's giving you what the processor is trying to execute and like the next instruction and everything. So assembly is defining like the most finite grain in like code. It's just lines. It's just one operation at the times, right? It's like the detail of the detail. So this is assembly. And every processor got its assembly like syntax, or let's say even architecture, because it's a whole architecture at the end. And yeah, so we are mostly working with Intel and working with like AMD processors. So we are dealing with something called x86 or x86-64 or x64. Like these are two the same. these are the same, and it's just the name of the assembly language for the Intel/AMD processors. Yeah, and then what? So we talked about assembly. So let's take a look. And a good way to learn assembly is by programming in C and then taking a look at what you have written in C has been converted into assembly. So you would make comparisons yourself. You would see what you have written has become as an assembly language, and you'd like make patterns and matches in your mind, and you would start understanding what assembly is actually doing. Same for crypto and chillmaster. Okay, so this is how assembly looks like. Right, I'm going to open it in Sublime Text so I could zoom actually. So this is better, and I don't think you'd need to install some. Wait a second, actually, I got Visual Code. We got a stupid thing in Visual Code right now. It's just an XML document from university, so excuse me on that one. Okay, so new text file. I'm going to I don't really use Sublime Text that much, but I think if I try to save this for fun, this d.sm, maybe it got some assembly highlighter. No, it doesn't. Okay, this is maybe there is an extension that we could actually install, and then it will start to highlight. This is ARM assembly. This is x86 assembly. Wait a second. I'm just going to install this. I hope it's not heavy. Oh yeah, it got installed instantly. Oh, okay. We started getting some highlight on this one. So good. Let's start reading the code right now after making a zooming. That this is so much zoom, but yeah, it's good for this stream. So as you know, I have talked about this in the finally. Okay, this is I'm an old man. This is why I'm using Vim. So as we have talked many times about this, the program, like your program, after getting compiled, is actually defined in sections. All right, and each section in the program. So let's say like this is the program. So this is the program. It actually got sections. So you get, for example, one section for called like data, and there is another section that is called BSS, for example, and there is another section that is called .text, and there are actually more sections defined in the code. So for the data, for example, this section will hold all initialized global variables. So if you have initialized the global variable, just like int x equals 5, not inside of a function, outside of a function, it's called a global variable, it's going to be saved in the data section. If you, on the other hand, initialize a global variable, but you do only int x, you do not initialize it, it will be saved in this BSS section, and when you write stuff to it, it will like overwrite like the BSS section. It will just write to the BSS section. You have the .text section, and this section holds your compiled code. This holds the compiled code to execute. So it will the processor will read from this section in memory, and it will read the instructions and execute them. So yeah, there are so many sections in the program, but yeah, I have only talked about what I have seen in this program now. So as you can see, the author has defined the data section, and he has defined some global variables like the win message, the value, and the FMT. And this DB thing is just define byte. So this is trying to define a bytes string, like a string basically. This is a new line. It's represented as 10 in decimal and 0xa in hexadecimal. And this is a null byte. Okay, so a null byte is just nothing. It's just used to like a special specifier. It's a specifier for the end of the string. So it will tell the compiler that this is the end of the string that I'm trying to write, basically. And there is something called value. It's equal to 0 or null bytes. And there's this FMT thing, which is %u. So let's see. And there is the section text. Now this is the real code. This is what the program is actually doing. It's all in the .text section. So global main, this is like defining the entry point, like where to start execution. So it's starting from this main, and it's doing some extern like call, and this will import library functions. Like I say, it's just importing them, but yeah, it's just like telling the compiler to make links for scanf and printf functions when doing compilation and linking. And yeah, this is all what we got in the repository. Yes, this is all. This is assembly 2 and assembly 1 only got these files. Yeah, there is no executable. So the main function is going to call scanf, and let me like show you a good way to read code. Like it's not always good to do this thing, but you could actually try to do this like in most of the times because it's helpful. So do not actually read every line. Do not focus on reading every line of the code like by itself and go in and go in. This will take time. On the other hand, what you could do is just throw an eye on the important stuff that will give you information on like how a block of code or like what a block of code is going to do. So basically, I didn't read these 2 lines. I saw a call to scanf. Okay, this is just taking input. I don't really care. So I just pass on. This is how you do it. You will learn to do it by time and by experiencing so many like samples in reverse engineering. But yeah, you will get to know this by time. And yeah, it's doing scanf. It's saving our input in the value variable, and it's doing fmt. Fmt is equal to %u, as we have seen above. This means that it's taking some unsigned long, so it's taking a big number basically. So let's not care about like all of what it's doing. You could actually learn more about assembly by yourself because yeah, I can't actually talk so much assembly in this live stream. Can you explain how linking works? Yeah, just in a second I will try to explain it to you. Then it's moving that value into some register. So you see this EAX thing, this EDX thing, this I don't know what else do we got here, only EAX and EDX. So these are called registers, and there are so many registers. There is EAX, there is EDX, there is ESI, there is EDI. There are so many registers. This is at the end just memory, and it's fast memory. So you could imagine that this is the processor. So this is the processor, and it's memory that is actually just so close to the processor. It's just like you could say it's under the processor in some architectures. So you got the registers in here, and you also got like the cache and stuff, like because the cache is also part of the processor memory. So these registers are just fast memory, and they were created as like to increase performance because back in the old days, the processor, when trying to retrieve data or when trying to write temporary data, just temporary data, it will go and ask for ask to read from the RAM, and the RAM should return that data, and like there is this whole path of going in and out from the random access memory. So registers were created, they are part of the processor. It's really fast to access them, to save data and gather data. So this is a good optimization, and yeah, so, and these are just the names of the registers, so nothing special for the moment, right? And they are just, you could imagine them like global variables. You put stuff in them, you fetch stuff from them, and yeah, this is it. These are what registers are mainly doing. So, and for example, in this case, we put the content of the value variable. When doing brackets, you are trying to access the content of the variable, and we put it in the EAX register. Then we have done a bswap. This will just inverse the bytes. For example, if you got 0x41 41 42 42, it will be 0x42, sorry, 0x42 42 41 41. So it's inversing the bytes. It's trying to read them in the inverse direction. So if you are reading it from right from left to right, you would need to read it from right to left. This is what bswap is doing. Keep up the good work, bro. Thank you so much. Glad you're enjoying the stream. Okay. So it takes input. It takes some number. Okay. Let's say we enter, for example. Yeah, it's hard for me to convert. Let's say we. let's say it entered 65. Okay, this will be converted to hexadecimal, and like let's say you entered some big number and it got converted. When converting it to hex, it will be 41, 42, 43, 44. So it will be saved in EAX. EAX will be swapped, so this will be in the reverse order. So 43, 42, 41. So yeah, this is what EAX is currently equal to. Then it's going to move EAX into EDX. It's going to end EAX with this number. Ending will just take... oh shit, I need to explain ending. I hate this. Okay, so let me explain. Should I explain the logical operators? Maybe yes. Okay, I will explain what he is using. What is he using currently? He's using the AND, the shift, the OR. Okay, he's only using this. So let's quickly explain this thing. So we got the AND, we got the shift. Shift is just Shift is just it would need some paste. So let's explain it later. So what the AND is just a logical operator, and when, for example, doing let's take the number 3 and let's take the number 1. All right, let's convert this to binary. It's going to be 1 1. Let's convert this to binary. It's going to be 1, like just 1, or 0 1. Like you could ignore the 0 there. So when doing the AND operation on these two numbers, what you are going to do is just skip the boring chords if you want. No, I'm not going to skip them because so many beginners are watching. So yeah, it's a good opportunity. So it's just like the AND when you are doing if comparisons, when like in Python doing if 1 or if x is 1, yeah, and then doing an AND y is 2. I don't even understand what you are writing. Shifting, if you are asking about the name of the thing. So yeah, it will, like, the two things need to match. Just like this way, when encountering the AND operation with integers, you are going to convert them to binary, and then AND each of the digits by the one that is corresponding to it. So 1 and 1, like ending 1 and 1, and 1 is just true and 0 is just false. So 1 and 1 it's true, 1 and false, true and false it's false, so it's 0. So this is what AND is doing. On the other hand, if we were trying to make this an OR, for example, and OR is like represented with a pipe, it's just pipe. So when doing OR, like true and true would give you true, true or false would give you true. So yeah, this is how OR works. On the other hand, you got this SHL, which means shift left, shift to the left, and shifting is a cool operations that actually got a meaning. It's just not bonsoir ce soir. It's not a random thing. So shifting. So let's say we want to shift the number 5. Is 5 okay? Okay, let's try to do 5 anyways. So let's try to shift the number 5. When converting this to binary, I'm actually thinking, well, let's explain it and then show it with some Python code, because I want you to see like how it's actually working. So okay, so the 5 is just a 1 0 0 1. So let's say I'm going to shift the 5 to the left. Sorry, this is the left. To the left by 1. So like this is the operator for shift. It's just 2 inferior than signs for the left and 2 superior, like greater than signs for the right, like shifting to the right. So shifting to the left by 1 will just take that number, like take this number, let's take it in here. So it's 1 0 0 1. Let me take another color, highlight this, and yeah, this is what shift will do. It will take the number bits, it will shift them, like move them by 1 bit to the left, and then add a 0 on the new bit, like the empty space that got there. So yeah, this is what shifting is doing. On the other hand, when doing shifting to the right, like to the right, which is just 5 1, for example, this will take this number 1 1, like 1 0 0 1, it will shift it to the left by 1, and this means it will take that number and move it to the right, to the right by 1 place, and this means we are losing 1 bit, because yeah, we just moved it to the right and there is like no more space to put the bits there, so we just lost it. Hey everyone, welcome to the stream. And we got a new number. Alright, which is just the number, oh yeah, sorry. Oh yeah, I'm being dumb. So yeah, this is what shifting is doing. And what else? So yeah, you might think that this operation is just like moving bits, and it's only moving bits, but in reality it's actually deeper than that. It's actually doing, you could imagine it, not imagine it, it's actually doing multiplication, and it's doing division, so it's doing both of this. And I will explain this, how is this happening. So let me get another black screen. So let's say I'm going to shift 5, or let's get like an even number would be easier to explain it. So let's get the number 4, for example. Shift it to the right, shift it to the left by 1. So this will do multiplication. And how is this really working? So if we take the number 4 is just represented as 1 0 0, and 0 1 2, yeah, another 0. So this is the number 4, and shit, I'm being dumb here. It's this. So this is number 4. Oof, and when shifting it to the left by 1, it's going to add another 0. Isn't 5 101? Yeah, I made a mistake. Instead of writing 3 digits, I wrote 4 digits. So yeah, when shifting it to the left, it will add a 0 at the end of the to the right of it. So we got a new number, which is 1000. So this this number got upgraded. Let's say it got upgraded, and I need to represent this. So this was the 0. This is how you read binary. This is 0. This is 1. Wait, this is when doing exponential. So it's 1 and a 2. You just go by a step of 2 and a 4. And if you got another digit here, it's going to be 8. If you got another digit, it's going to be 16, and so on and so forth. So you are just taking the current number, multiplying it by 2, and moving to the next digit. So this is number 4. Okay. The new number that we got is just number 8. So 1, 2, 3, and wait, that's not a 3, that's a 4, and we get 8 in here. So it's number 8, which is just 4 times 2, which will be equal to the number 8. And why did this work? Because when you represent this with powers of 2, this will be 2 to the power of 0 times 0 plus 2 to the power of 1 times 0 plus 2 to the power of 2 times 0 plus 2 to the power of 3 times 1, which is the last guy. So it's 0, 1, 2, and 3. And when we have done the shifting, like when we got from this number, we got the 2 to the power of 0 times 0, the 2 to the power of the 1 times the 0, and the 2 to the power of the 2 times the 1. So we have shifted this to the left by 1. This means that we have multiplied this by 2, because when multiplying this thing by 2, it will be 2 to the power of 0 to, like, this 0 will stay. But from, like, what I mean, when multiplying this by 2, all these powers will upgrade. So this 2 in here will be a 3. Alright? This is what would happen, and it's upgrading like the exponent. And this is why it's just multiplication by 2, because as you could see, this became a 3, this is a 2, that's a 1, and this is a 0. So this is why shifting to the left is a multiplication. On the other hand, when doing shifting to the right, it's going to decrement the exponent, and it's going to be like, it's going to make division, basically. So yeah, this is just basic binary stuff, basic base converting, and you could read more about this online. But yeah, when you see shiftings, it's always multiplication. And why am I even talking about this? I'm talking about this because compiler makes so many optimizations. And when compiler optimizes code, for example, you do 3 times or like 4 times 2, just like we have done, it won't like the multiplication operation is actually heavy. It's called mult. There exists a multiplication instruction for assembly, it's called mult, but the processor doesn't like it because shifting to the left is actually more optimized. So it's going to convert this multiplication into a shift, and it's going to be 4 shifted to the left by 1. So and some decompilers might fail at telling you that this is actually multiplication, just like Ghidra would actually fail at telling you this is multiplication, and you might be lost, and yeah, you might just think, oh, what is this shifting is even doing? On the other hand, it's just multiplication. There's nothing special with shifting actually. So yeah, I hope I actually explained this. I hope I did. Okay, what else? Okay, yeah, what's the Leia instruction? We're gonna see it. Is it in here? Is the Leia instruction in here? Let's search for this Leia. There's no Leia. Okay, I will explain it to you. So, you know, the move instruction is going to move data like between the register or like between the memory. There is also another thing called Leia, and Leia is going to actually copy. It's not going to copy, but it will let you move like data after having operations. For example, you could move into the RAX the 1 plus 2 plus RDX. Okay, this operation could not be done with the move instruction because the move instruction, when it sees this brackets, it will try to fetch, it will like reference this as an address. I'm talking about the move. It will try to read that as an address and try to access it and read data from it. But it's not actually a valid address. We are just like adding some numbers. This is why you use the Leia, because Leia will let you actually define instructions in the brackets section there. And yeah, this is like the main purpose of using Leia. You might also use Leia in order to copy an address, like not the data inside of the address, but the address itself into a register, like this, for example, the value. If I do Leia RAX and value, it will copy the address of the value variable into the RAX. If I do a move RAX value, it will actually access the value and give me the value of the value variable. All right, this is giving the address, this is accessing the data and getting the value from it. So this is the main difference. Okay, so let's get back to what's happening in here. So it takes input, it swaps my input, and it will separate my input into 2 chunks. All right, it's actually taking every like, let's say my input is 0x41, 42, 43, and 44. When doing the AND operation on the EAX, it will remove, this will be 0, because ending anything with 0 is 0, so we get zeros in here, and we have 1, 2, 3, and 4. Then it will shift that to the left by 4. That means that we will get another bit, because 4 bits it's just one nibble, it's just one hex digit, so we'll get a 0 in here. Then what? This gets set back to like 10, so you could ignore this one. It's a 10, 20, 30, 40. So for example, like from our input, then it will actually do another AND operation. This time it's going to take the digits on the left, so it's going to take the 4, it's going to take the 4 again, it's going to take the 4, because it's 41, 42, 43, and 44. So it's just taking 40s, and it's going to shift to the right by 4. This will remove this 0. All right, then it's going to OR these 2 things. Okay, and the OR will just, if you OR anything with 0, so A, for example, A ORed with 0 is just equal to A. So anything you OR with 0 is equal to itself. This means that when ORing these 2 numbers, we will get 0x4, 1, 4. Is it this thing? Yeah, this is a byte, this is a byte, this is a byte. Oh no, we are not going to take that. Oh, I see what it's doing. 0x, let me just rewrite it for you to get it. So 20, 30, 40. This is the thing before doing this end. And we have the 0x 40, 40, not 40, sorry, 0, 4, 0, 4, 0, 4, and 0, 4. After having this end and shift. So when ORing these two numbers, you will get the 0x 1, 14, 24, 34, and 44. And what this did actually do, it actually swapped the bits. So this was 0x41, it became 0x14. So it just swapped the two digits, or the two digits. Okay, so this is what the first block is doing. We could comment this. So this will just swap the hex digits from our bytes input. So yeah. Then we have this code, and this is ending with some 3s shifting to the left by 2. So it's going to multiply by 2, ending with this and shifting to the right by 2. Okay. And then ORing them again. So the 3 and the C, if you take a look like at the binary format, a 3 is this. It's just 1, 1. So when you end anything with a 3, for example, the 0x41 again ended with a 3, it will give you. So let's take a look at what the binary representation of 0x41 is. It will actually just give you 1. So it will give you the lowest bit, or the lowest 2 bits of the byte. And this, on the other hand, bin of 0xc will give you the higher 2 bits. What this means again, it's trying to even shift the byte, the digit itself. This makes it weird, and then he's gonna make it with the 5 and the A. The 5 and the A is just okay. It's just taking again some weird format of the bytes. Then what it's going to do, it will compare the result with this number. All right. So this is actually the number that you should input. The number after like doing all the shifting and the ending and all the stuff. This is what you should end up with. So if we reverse this endings and shiftings and everything, we will actually get back to the input and know the correct value for the value variable, all right? But just a second. So we need to understand how to actually reverse this thing. So yeah. Let's actually start by doing it one by one. So we will start from the bottom to the up, because yeah, this is the state of the input after the last encoding block. So I will take this this value, I will call it EAX, and let's reverse this block here. So yeah, or actually there is another approach. You could brute force, but you are going to wait for a little bit. So yeah. Okay, so this is EAX actually. This is EAX. This is comparing our input after encoding to the encoded result. So I will take the encoded result and try to actually decode it, I would say. So yeah, EAX is equal to that. There was some addition with some constant. So I'm going to take this constant and subtract it from EAX. This is EAX minus that. So EAX is equal to the new value. This is EAX. Okay, it's negative, all right? This is because an integer overflow happened. You could read about this from the last live stream, but you could make a workaround around this. You could just end it with 0x, 0x 1, 2, 3, 4. So I just entered 4 bytes as f because this is the maximum value, and so it will just give me all of the 4 bytes that I should get. And it will ignore the bit sign because the bit sign is actually on the most left side of the representation of the number. So it will ignore it and only give me the 4 bytes in here. This will give me the correct positive number that it was dealing with. So now what? Now we are just going to. So this is actually we could separate this into 2 blocks. All right. So we got the end with the EDX, we got the end with the EAX in here, So we need to, okay, then there's some shift and there's some OR. So we need to get the EAX block and we need to get the EDX block, like separating the OR. After it did the OR, we need to separate it again. So what to do actually to get this one is, let me end the number again with these numbers so I get the same parts that he was playing with, because you know the 555 thing when done as bin, when done as bin, this is the number. It's always taking like the half of the digit, so half of the digit, half of the digit, half of some digit. So yeah, I will end it again to take the same part that he actually took after ending. So I will just end it with this number, copy EAX, and with this I will put it in some X variable. The Y variable would be the EAX ended with this other thing. So yeah, we got two variables now, hex of X and the Y variable. So we got two variables, two parts. And now what to do is, so after like getting the separated parts, like the bits that he is manipulating, we got the bits that he is manipulating. Now we just need to reverse the operation of the shifting and the ORing that he did. So, well, at the first place, you got this part. This part has done a shift to the right. So and sadly, a shift to the right would lose you a bit. Right, you would lose 1 bit when shifting to the right. So it's not actually reversible. It's not a reversible operation. But remember, let me show you the binary format of the A so you understand. The last bit is actually a 0. So when it does a shift, it's removing a 0. We already know the value, so it's just a 0. And you know, when taking a number like the bin of 1 shifted to the left by 1, it will add a 0. All right. Shifting this is 2, so when doing 2 to shift to the right by 1, it will just get like remove that 0. So we know that the value is 0 at the end. So in our case it was like reversible, but in some other case doing shifting to the right is actually not reversible. So in some cases, so yeah, like it's not a proper division, you know, then it's not reversible. Okay, so when he did a shift to the right, I'm going to do a shift to the left. So I'm going to take the X variable, the X variable. Is it the X variable? No, it's the Y variable. We ended it with this. So it's the Y variable shifted to the left by 1. Okay. And this way we recovered the EDX part. Now we need to recover the EAX part. We will just do the same thing. He did a shift to the left by 1. I will do a shift to the right by 1. So let me just do that, and I'm going to make the OR because he made an OR. I'm just going to OR again. This is the OR because I have separated it into two parts, and then I need to OR them back after like inversing the shifts. After inversing the shift, we have separated this into EDX and EAX, inversed the shifts. Now we need to OR again to make it another number. So yeah, OR it with X. He shifted it to the left, I will shift it to the right. So this is EAX, this is the new EAX. Alright, you could take a look at it. So this is the new number. Alright, and we will do this, we will apply the same logic to these blocks, and yeah, we should have the flag. Again, this is doing a shifting to the right. You might think it's actually not reversible, but when you take the binary format of this C, you could see that the last 2 bits are just zeros. And yeah, he shifted by 2 bits to the right. He lost 2 bits, but we know they are zeros, so we could just shift to the left by 2, and we will get the same number. So I will just apply the same logic. We got the EAX. I will separate the EAX into some X and Y variables. So let's say X gets this part of the 3s. I actually missed the 3s thing, so I need to recopy the number. Whoops. So this is the number. And this is the Y variable. Y is equal to AX and this. We got 2 numbers. Now we would need to make Y shifted to the left because it shifted to the right. So I'm going to shift to the left by 2, or it with the EAX shifted to the right by 2. This is 2. Yeah, it's 2. And this is the new EAX. Now only one layer is left, which is this one. Again, we will apply the same logic. So we will separate the EAX into some x and y variables and just do the same thing again. So this is the x variable, this is the y, this is the y variable, and we need to make EAX, I will just, yeah, this is good. So x, or like y, shifted to the right, he shifted to the right, I'm going to shift to the left by 4. Now I'm going to OR it with x shifted to the left because he shifted, to the right. Because he shifted to the left, I'm going to shift to the right by 4. And this is the initial number that you should have. This is your initial number. So if you convert this to, is not shift left similar to multiplication? Yeah, it's similar to multiplication. You could do a division in here, but yeah, it's not needed. You could just apply the same shifts because it's just losing zeros. So yeah, it's reversible. So this is the number that you should enter. All right, this is the number you should enter to solve the challenge. I will save all what I have done in some place because I might have made a mistake and I need it. So now how to verify that the flag is correct, because we don't have access to the platform. Well, I could take a look at the flag, right? Okay, it's this. Okay, it's not the same hexadecimal actually. So we might have made a mistake, like when doing this, when doing the reverse operations. I'm not really sure, but good job for the time and the effort. Yeah, I think I made a mistake. So yeah, I'm not going to redo all of this, sadly, but yeah, I can make the mistake somewhere. I'm not sure. We saved all the hex. This is the new hex of the EAX 29. This is the last one. We made the mistake somewhere. I'm not really sure. I'm really sorry. But yeah, at least we have tried. At least we have tried. Also, let me show you a good way to approach this type of challenges. Like when somebody throws so many assembly in your face. What you do is take the assembly code. You will take the assembly code. You will create a file with the assembly code. So let me call this asm1. So what was it called? 1.asm, alright. Yes, so this is just the file with the assembly, and then compile it yourself. Yeah, I'm just going to compile this. Okay, yeah, what a good day. File format not recognized, reading as length of script, LD error. Because I'm dumb, I'm really sorry. You need to use the netwide assembler in order to compile this. So there is something called the NASM. This is a netwide assembler. It will compile assembly for you. So this is the help menu because I haven't used it in a really long time, sorry. So I'm going to select the format. The format is going to be L32. It's 32 bits because it's using registers with the E prefix, and you know, E is for 32 bits and R is for 64 bits. So when you see RAX, for example, or RSI or RDX, you know it's 64-bit. So it's 64-bit. Any other options to actually mention? Maybe not. Maybe not. So we could just do elf64 this. We get an object file, which is our compiled data, but it's missing the linking. So now we need to link it, and we will use the the LD. So LD is just a loader / a linker. It will make links between your code, the sections, the functions, and the labels and everything. So, but yeah, again, I forgot how to use it. I need to take a look at the help menu. And okay, how does this work? How does this work? How does this work? So the help menu is actually long. What task is this? This is assembly 1. Okay, so could we specify? Okay, we could specify the output file. We could specify no symbolic, no copy, symbolic, whatever. This is not needed. I don't care. I will let the linker decide what to do. These are protections. I don't care about protections. And is this all? Don't you I think we need to provide like something else. It's just about providing the format, and this is it. I don't think that's actually the case. I'm not sure. Emulation size. Okay. Okay, yeah. Let me give it the format then. Where's the format? We have seen the format, right? Okay, I'm starting to lose my mind. Let me get the manual. The manual is better to read. Alright, it got examples. Oh, also another thing. You don't need the linker. Probably you could use GCC to actually compile this. Yeah, you cannot be used when making a py object. Oh, you could do fpy. Oh, no, wait. I think, no py. Yeah, it worked. So PIE is just like making addresses random in memory of the program. So, yeah, now I got an executable. I could execute it. But yeah, it's not working. But yeah, the idea is not to get that like thing to work, but the idea is to take the generated program and pass it to a decompiler. So let me save it on this system. Oh, I already got a test. I don't care. But where's the new test? This is dumb. I'm going to rename this to something else because why lose time? Why lose time? Okay, now we could just move it again. So this is the program. It feels like huge. Maybe GCC didn't actually do the correct job, but we might try and see. So the YT folder, we'll copy it here and we'll pass it to IDA. Do not save. Open this, and it worked, but it didn't. Maybe it decompiles it. I'm actually waiting. So like you are doing this just to decompile, like just to take it. To get a decompilation, because decompilation is very simple to read more than actually reading the assembly itself. So this is why we have done this thing basically, and yeah, it's just doing the ending, the shiftings, the endings, and this was detected as a multiplication because it's a shift to the left with 4, and yeah, it's 16 and so on and so forth. But we have actually tried to reverse it, but sadly we didn't get the correct number, and I'm afraid I'm going to lose more time trying to fix this. So I will pass to another challenge and have some fun, because we actually lost so much time on this one. So yeah, let me get to the. Yeah, he said that the rotation is the third challenge. So let's see, where is rotation? This is rotation. Rotation.py. Oh, it's a Python program. Okay, let's reverse Python. Let's read Python code. So this is Python. It's taking some input. It's taking your input. Sorry, it's taking your input, and then it's going to loop on the input, take each character of the input and remove like some integer, which is just the index of the character. So it's like, let's say the flag is equal to Securinets something. It's going to take the S character, so S minus 0, because you know it's index 0. Then it's going to take the E minus 1. So each character is just subtracted from its position and added to some output, and then it's comparing the final output with some encoded string. So the idea is simple. You just take this encoded string and you would make a loop on this one. You would save it. So let's say X is equal to this. Then I'm going to loop on this one, and I'm going to, so he subtracted the position, so I'm just going to add the position. That's all. Just sorry, I need to loop on the position. So let's say X, I'm going to call it encryption, so it's like better for a reference. So enc of I plus I for I in range the length of the encryption. Okay, so convert the decimals to characters, to ASCII characters, you get the flag. It was just that simple. It's just like a basic rotation, basically. He just rotated the characters by adding a constant. Rotation is super easy, so yeah. This was the Python challenge. Can you actually tell me what the next challenge is, if you are still watching? Where is the GitHub repo? It's here. Is the screenshot in here? Oh, you got, no, it's not in here. Maybe, no, the screenshot is not in here. No problem. Okay, I don't want to guess. I just want to solve simple challenges for the moment. GDB 101. All right, GDB 101. Let's see. We got this binary, GDB 101. So for anyone that doesn't know what GDB is, let me move this to mark it as executable. Sorry. Oh, I made mistakes. Let me execute this, and all what he said is run me in GDB and keep looking at the registers. The flag will be there. So GDB is just the GNU debugger. It's just a debugger. Let me open it for you. It's just a debugger. It will let you run the program, and it will let you set breakpoints, like to break on the code and see memory and investigate the memory and like look at the different registers and different values and different instructions and everything. For example, if I break it on the main function, like this is the way to set a breakpoint. Once the GDB will hit the breakpoint, it will stop execution and give you some interface. It's my LinkedIn account. You can even watch your latest live. You'll find the list. Oh yeah, that's correct. Right, let me run this one, and yeah, it's stopped execution at the main function. This is the first instruction in the main function. This is the assembly of the main function. These are the registers on this part. This is a view of the memory. This is the memory basically, and yeah, there are so many parts, but yeah, in this way you could see what the program is actually doing. All right. You could just do ni for next instruction and execute the next instruction so many times, and already you could see this funny values. These are the flag characters. Okay, they are being copied into some memory, and then there is something that would happen. So we could actually like let it copy all of the characters. We'll just let it copy all of the characters. Now it copied all of the characters. This is the null byte terminating the string. What I could do now is disassemble the main function again, and I'm going to take a look. This ended execution, like this completed copying in here, and I could, so the first character got copied into this memory, RBP minus 0xC0. I could just copy this thing and x/s, which will examine as a string the memory at RBP minus 0xC0. Oh, okay, we are having a bad day because this is probably UT. Okay, yeah. It's not saving them like one after the other. There are null bytes separating the value, which is really bad. So in a second, I will. I have another idea actually. Like instead of actually going that way. Oh, there is an strcat here. So okay, I will break at the strcat, so, and continue execution. strcat is trying to cat probably the flag, the RDI register. No, it's not. Okay, just a second. Disassemble main. It's trying to, RDI is the first argument, this is the second argument, and use pound debug. Yeah, pound debug will give you arguments, but it's not a problem. I'm lazy to switch. RDI. Where the fuck is RDI? Oh, RDI is REX. This is RDX. So it's going to copy into this memory. So let me, next instruction to execute the strcat, then examine this memory. Still getting this 4 bytes thing even when you read from the second argument. Yeah, you get that thing. It's always going to do that, but that's not a problem. Let me try to execute the strings because I'm too lazy, and strings with the EL, no flag. Is there a big Indian thing? Encoding LB. Oh, with L, and there's a B for the big ending, so EB maybe. If it doesn't work, then I'm going to do it the hard way. Let me do trace. It doesn't work. So okay, we need to do it the hard way, sadly. Either use my pawn debug or concatenate the characters myself, like in a whole sadness, because yeah, they are separated by some values. Or you could just make a telescope. Take a look at. Oh, this is so sad. Okay, I'm starting to hate Jeff after this challenge. Wait, I think I have actually looked at the wrong stuff. I think I'm losing track. Just a second. So C0, this is separated by 4. It's going to try and copy into this address pointed to by this RAX value. Doing this. There's a little problem that I don't understand, because it's trying to 32 and 30 like this. This doesn't feel correct. We are losing viewers, and yeah, I'm starting to panic. So, but there is no problem. There is no problem. Okay, I will activate my pawn debug extension just like the author said in a second. So let me get my GDB init. I need to take. I need to find my pawn debug. Just a second. So sit here. The script for pawn debug. The script for pawn debug. Scripts. Docs. No. I really forgot where it resides. Is it in here? Pawn debug. No, not really. Okay, just a second. Pawn debug GitHub. Pawn debug. What line will pawn debug add to the GDB init? It doesn't show it. I'm hating myself. Just a second. GDB history. Where's pawn debug? GDB Jeff. GDB init history. Git config. Maybe this one would help me. No, this is my git config. Sorry. I'm sure it's in the pawn debug folder. I'm just losing track. Pawn debug. Debug. Okay. Log. Load. If you could also see like the file on your system, that would be so helpful. If you could just see it. Like, give me the line it's including pawn debug from. Otherwise, I'm going to ignore everything, because yeah, it's starting to drive me crazy, and I'm going to just do this. So I wanted to show you the debugger, but yeah, at the end it's just solvable by disassembling the main, copying these things, getting to Sublime Text, removing these 2 lines because I don't want them, and then removing all of this data. Just let the first go. Let's remove this. This was 65. Remove all of the new lines. This. Okay, now you got the string. You could take it, get it into Python, separate the values with 0x. You will have all of the hexadecimal representation of all the characters. Now you could just loop and decode. So you could just do that, but yeah, I just wanted to use the debugger. But yeah, anyways, it's not a problem. And whoops. Okay, yeah, with the S character. So this is the flag. GDB is your friend. Sadly, I didn't find the initializer for pawn debug. That's not a problem, anyways. Let's take a look at GDB 102, and this is the binary again. So also using Arch Linux is bad, because you will get like this bad environment, and it's hard to manage stuff in like a fast manner, but not a problem. Let me download the binary, mark this as executable. So this will ask for some input. debugger detected. Okay, it detects ltrace. This is good. It's detecting ltrace. Let's run strings. Let's see if we get any info. We actually get this. It wasn't your it wasn't your friend this time. Yeah, it's my enemy this time. We got this string which seems like the flag, but it's encoded in some way. So you might actually I don't think this is reversed. I can't read it when, like, even reading it from right to left doesn't seem to make sense. But you could try to make basic rotations. Like, let's do rotations and see if this is actually if this makes any sense. You could just guess stuff at the beginning before really doing reverse engineering, especially in, yeah, it's deeper than you think. So we solved this challenge without even doing reverse engineering, just by using dynamic analysis. Yeah, we just solved the challenge using dynamic analysis, and that's it. So you could just take the string, enter it in here. Yeah, you found the treasure. This should be the flag if I take a look at the GitHub repo. So write-up.c, yeah, this, no, wait, let me take a look at this guy. This won't define it, but that should be the flag. So yeah, I don't care. Let's go. So next challenge, can you, yeah. I need to find the challenge name myself, I think. So let's get some LinkedIn. Here you go. Let's get to your profile, and nice profile picture. So where's the picture? How to see all the posts? Okay, let me see. Okay, these are the challenges. Nice. Okay, so we have solved all of these challenges. Now we are going to deal with. We have also somewhat solved the assembly one. We didn't actually. We made mistakes, but yeah, we are dealing with the UPX. We solved also the GDB2. Where is GDB2? We got a donation. Switch to Pound Debug next time. I need to reconfigure Pound Debug, I think. Okay. Yeah, I was doing so much binary exploitation in the last weekend, and this is why I just had Jeff there installed. So, okay, we solved this one. We solved the GDB02. This is it. Oh, it was marked as like 1000 points, and I have just solved it with strings. So yeah, everyone, strings is a good tool. Remember, let me actually try to debug it. So all what you have made is just add like a ptrace to detect my debugger. All right. If I disassemble the main function, you are calling another function here. It's being called. So let me take a look at this function. This function is also calling another function. Okay, you're making this fun. And this function is calling ptrace. So ptrace is just, it will kill the process once it detects that a debugger is actually debugging the current process. So it will just kill it. It will just exit. And you will allocate stuff, you will take some input, and it's because it's worked with, yeah, I know that. Then try passions is key challenge. I will try it after explaining this one. Then you have this this function. This function is calling this function, which seems to decrypt, maybe decode the flag. I'm not really sure. But the way to bypass anti-debugging in this case is just by let me get to the function with the ptrace call. I think this is it. Yeah. It calls ptrace 2 times and it makes comparison everything. You just break in the instruction that is calling ptrace, which is the function plus 33. You just add this decimal to the function name and you will break point there. Then you could run it. It will break point on the ptrace. So we are just calling ptrace, And as you know, the return value of functions is saved in the REX register. That means that you could execute this instruction, and then REX is -1. That means a debugger is detected. Hey, what's up? You could actually set REX to 0, and it will just not notice the debugger. There is another call to ptrace. We have REX set to -1 again. We could just set it to 0 back to 0. Go, and yeah, we have bypassed anti-debugging just like in this way. There's nothing special. Enter the treasure code. It will allocate stuff. It's taking my input. I will enter this as input, just like creating patterns in the memory to make it easy to see them later. And it's calling this function, so let's get in. Single instruction, single step. It's calling another function. Maybe I should get in, maybe not. Let me take a look at the disassembly of this. Is it even calling another function? It's calling this function. Oh, it's not calling any other function. So maybe this function would have the business. So let's just do single step, like single instruction to enter the function body and start executing this function. I will just zoom out for a little bit just to make it easy for me to see stuff easily. Because yeah, when reverse engineering, you need to see as much information as you could. And yeah, you could see this the encoded string that we have seen using the strings, and you could just single step through the assembly code until it does the rotation. And wait a second, there is a smart way. So this function is executing after taking input. It will, when is it comparing my input to that thing? So when does the comparison actually happen? It's not happening here, most likely. It's not happening here. So it's happening inside of the function. Where is comparison? Where is comparison? Maybe it's comparing it character by character, which is this compare. Maybe it's this comparison. There is a high chance it's that comparison. Chill stream man, thank you so much. Or maybe it's just another comparison, you never know. But there's a loop in here, most likely. If I just go into the code, like just single instruct through the code, I think it's going to, is it inverting it right now? Is it making the inversions? It doesn't seem like it inverted any characters. Is it making comparisons while looping? So, oh, it's actually rotating my input. It's going to rotate my input. Okay, yeah. So you just need to follow the code with the debugger, understand that it's doing rotation to your input and comparing it to some result, and yeah, you got the flag. We got the flag in a more easier, direct way by just guessing that it's rotation, and yeah, that's it. And this works in like many times, even in real world. It might sometimes work. So yeah, next challenge is UPX. So let me get the UPX. Oh, he said try passions is key challenge. So let me try the passions is key challenge. This challenge is, where is this challenge? Okay, it's in here. Okay, it's a Python challenge again. Alright, let me see. Just a second. So yeah, this is the Python code for the challenge. There's some a variable containing the funny decimals. This seems like printable though. Anyways, it's using a in here. It's looping. Is it looping? No, it's not. It's taking some input. I'll give you flag of some character, like flag of x. Okay, you enter an integer. It will take the integer. And not the, oh wait, I made a mistake. Passions is key. What did you, oh, the PyC? Is it the PyC? I'm really sorry for reversing the code. I thought like that was just created because you imported some stuff. Because the PyCache directory will be created when you import modules. Okay, not a problem. I will reverse engineer the PyC. So make a directory. Passions is key. Passions is key. Download the challenge. And yeah, this is compiled Python code. So Python is compiled to a virtual machine, which is a stack virtual machine that will, like, it's just a lower level representation of Python. It's just some optimized Python. Not a big deal. Yeah, I haven't read all the lines, but yeah, it's obvious what it's doing. So compiled Python is not that hard to reverse in most cases. So because decompilers exist, but for new versions of Python, decompilers would not work. So yeah, you just need to reverse the assembly from the PyC, and I will show you how to get the assembly. But there is like a famous decompiler. You could also use online decompilers, but there's also like PyCDC, which is the decompiler I actually, and the disassembler I enjoy using. It's just a Python bytecode disassembler. You might try it yourself on the challenge if you haven't. I've sent this, and yeah, let me try it on this one. So PyCDC, run this guy, and yeah, bad magic. So why did this why didn't this work? Because probably this is a new version of Python. All right, and you could actually get the version of the Python from the first like magic, from the magic bytes of the file. All right, you could actually get this, but there is also something called PyCDAS, maybe. Yeah, PyCDAS is just also bad magic. Okay, maybe I'm doing something wrong at this point, because like this assembling should work in most cases, but okay, path to the PyC file. This is Marshall code objects. Both tools support Python code as output. It also supports marshalling and everything, so it should work, but it didn't. Probably it's a new version of Python, so let me try to import this. Open the file. Passions is key. Read it as bytes. Save it in some data variable. Close the file. This is the like bytecode of the PyC file. And I could use the this on the D, and yeah, this, okay, you need to do marshall.loads. Maybe it runs only on Windows. Yeah, that's also a thing. Okay, I will try it on Windows. I will just try to do the Marshall thing first. So import Marshall. Like Marshall is just a way to how do you say it? Serialize data, basically. So this might be serialized, and we might want to serialize it, deserialize it. So we're gonna run the D on it. Okay, bad Marshall data. This is for sure not a Linux file. Okay, so let's try it on Windows. Let's download this on Windows. Sadly, I don't have the PyCDAS on Windows. I'm not sure if I could install it. Okay, you need to compile it yourself. We might let him cook. We might. Yeah, I didn't try running it on Linux. Okay, it runs on Linux actually. Yeah, it runs on Linux. It's not only a. We need a setup tour. It's I don't have a big like setup. It's just an Arch Linux virtual machine, a Windows VM that I want to upgrade to a Windows 10 VM. Like I got the correct IDA version. I got some other tool links for Windows, and I just use it for reverse engineering stuff that I suspect as malware. And yeah, there's my main system. This is my main system. It's just Windows 11, and yeah, that's my desktop. That's it. I don't really have a big big setup here. Okay, so let's get back to this. So it actually worked on Linux, so maybe it's not just a Windows thing, but however there is also a problem with Windows files, because there is that like when saving files on Windows and then taking them to Linux, there is like a little problem that might happen, but I thought the problem would only happen on Windows and not on Linux. Hey, I'm a huge fan of you and your teammate. I've read the reverse engineering docs you worked on together, and they are really impressive. Also in the Securinets squads, amazing challenges. Thank you very much. Thank you very much. That actually means a lot. That's like, yeah, that makes me happy when I hear these kind of messages. And yeah, shout out for Ironbyte. We've made the documents like 2 years ago, and yeah, it was for some local workshops, and then we published the local like papers and pushed them to GitHub. So yeah, big shout out for him. We actually had a good time like doing these workshops like back in the days. So yeah, thank you again. Okay, back to the PyCDC. and I hate Python. All right, you could actually get the version of the Python. That's not a big deal. You could get the version of the Python from, only the real ones know about those documents. PyC file format. So every file got a file format, as you know. The PyC got also a file format, and in the file format of the PyC file, you could find the version of the Python through the magic number. So there's the magic number. This is the, oh, I was dumb too. Yeah, I made like a really dumb thing. When unmarshalling code, you need to skip the first 16 bytes. That's a big mistake I made because I didn't really play with Python compiled for a while. So let me get this again. So read as bytes. D is f.read. Close. Import the marshal. Import the this. And okay, then we're gonna skip the first 16 bytes. We're gonna do marshal.loads. Now we hope it works. Okay, yeah, it loaded the marshal serialized code. Now we could save this into code and then do this code. And this is the disassembly of the code. You see, this is the disassembly of the Python code that was written. Sadly, PyCDC didn't work for me because I use the Arch Linux, and yeah, fuck Arch Linux, because sometimes it makes me get like into real bad headaches and made me lose my mind and get into bad situations too. So you could actually reverse this Python code. It's not that hard to reverse this Python code. It's just a stack virtual machine. You know, stack virtual machine. You have the stack. It's going to push data here. It's going to pop data, and yeah, it always got access to the top element, only the top value, like the last saved value. And yeah, this is Python. This is the Python virtual machine. We could reverse engineer it together. There's no problem. So, for example, it's loading some constant. It's storing it. Let me zoom in. It's loading this constant. This is a constant. It's that big array, and it's storing it into some variable called a. There is also an import of the time module and storing it in some time name, and it's going to call the function local time from the time. Like this is doing time. It's doing time.localTime. Okay, and it's saving it into the b. So this will be b equals time.localTime. So you see, it's easy to read the code. It's not really that hard. Then it's going to load the b, and it's going to pass it to some like get some attribute from the b and store it in C. So it will be C equals b.tm hour. Yeah. Then it's going to print that value. Push null call. Oh, this is printing nothing, I think. Then it's going, wait, unless this is bad. Oh no, it's, yeah. This is printing just a new line, and this is printing passions is the key. Then this is printing the author and the stuff. Everything is printed. Then it's taking my input. You see, we just read the input. We just see the input keyword, and we know this is going to read my input. And it's saving it into some X variable. Then it's comparing it with 0 if it's compare operation. So it will, when handling compare operation, it will pop like two values from the stack. So the last one is no, it will take them in this order, sorry. So it will compare if X is smaller than 0, basically. So if it was smaller than 0, then jump if false to 224. 224 will execute another code. Alright, it's doing another comparison, and yeah, and so on and so forth. So if it's actually smaller than 0, it's going to execute this code and tell you, are you actually serious? And you could test this. We could re-execute Python compiled code, enter -1. Are you serious? We got another donation from Jihad. Great live stream, man. Keep going. Thank you for the donation again, Jihad. That actually means a lot. Okay, then it's going to exit, so it's not going to continue execution. On the other hand, if you enter something that is greater than 0, it's going to load your input, and it's going to binary up mod. So this is the mod operator. It's going to do xmod24. So you always, like, all operations will take this as like their parameters, because it's like some virtual machines. So it's doing xmod24, and then it's loading the C, and it's comparing. So it's comparing all of this block of code, like the result from that block of code, with the C. So this is just going to be xmod24 is equal to C. And then it's going to print, here you go, and it's going to show that character exorted by the C. So basically you just enter the position of some character. Okay, too late. Yeah, thank you so much, because I forgot one thing. I forgot one condition. Okay, I forgot one condition, that it's probably comparing time and I didn't see it. Yeah. If they are not equal, the C, what was the C? I forgot what the C was. The C was the hour. Okay, so you can only get the character of, like, the current hour. So for example, what time is it? So let me see. Okay, it's 22 on my Linux VM. So if I enter 22, I will get the character. You can only get the position of the current hour. Time 24 patience. So yeah, time, like, patience is the key. Okay. And at the end of the day, what it's doing, it's going to XOR that with the C, like the current hour, which is at the end the position of the character. Like, because yeah, xmod24 needs to be equal to the C, so it's just the position. We need more people like you in this field. This reminds me of some funny message. Thank you so much. Okay, so it's just XORing it with the position at the end. What you could do is take that array. This is the array of the encoded characters. Let's take this. Save it in a variable. I will call it A2. Loop on the A for I in range length of the A. And challenges, passions is the key. It's this one. Passions is key. Okay, then you do A of the I, XORed by the I, you get some characters, you convert them to characters, and yeah, this is the flag. Join this. This is, oh, fuck me, I made a mistake. Oh, wait, yeah, I forgot one thing. I mod 24. Yeah, here we go. We just forgot to mod it with 24 because he's doing mod 24 in here. So yeah, I just forgot that. So yeah, you got an idea about how to reverse engineer Python, but I'm not going to lie to you. I actually don't do that because yeah, it's time consuming, especially in hard CTFs. So what I would actually do is just say hello to ChatGPT. Yeah, just want to write a message. Okay. Convert this to Python pseudocode. At least AI is doing something right now, and it will just try to convert that thing to some Python pseudocode, which is actually correct. This is very similar to what we have seen. So yeah, this is what I do. Some other players kept changing the time on the system to get the letters. Like, I actually cannot believe that. I would never do that. You need to be so lazy in order to do reverse engineering. Like, you need to be really lazy. Also, I want like to ask you a question. What is the version of the Python that you have compiled this with? Let me try and find it. Hexedit. As I said, it's just the magic bytes. Even the solved quests elibat. Seeing the write-up now, I love the challenge. Yeah, magic number PyC. Like there is like on GitHub, I think this is it. There is on GitHub a list of the magic bytes for all of the versions, and it seems like I need to convert this to decimal. I also don't know if the magic is 4 bytes or is it only 2 bytes or like what. This doesn't seem correct already. Yeah, it doesn't seem correct. Let me see. Is the magic number... Where is the Python file format thing? Did I remove it? Oh, I removed that. Okay, let me Google again. PyC Python compiled code file format. I just want to know 3.12. Yeah, I didn't update my my PyCDC. This is why it couldn't decompile it. But there's also a trick to make PyCDC decompile the versions that are not supported yet, and it's basically by going to PyCDC. There is like in the code. Let me just find it really quickly. bytecode.cpc. Is this a thing? Okay, let me just use my GitHub because this will be faster. We could search. We could use the search thing. So let me search for magic. Okay, you could see these are all the magic numbers, and on my PyCDC, because it's not updated, I've been using this for like 2 to 3 years, I think. So yeah, it's actually very old, and I need to update it. But yeah, this is CB0D0D0A. If you search this in here, sorry, do you need to skip something? Oh no, it's like in the inverse order. My bad. It's little endian. So 0A, 0D, 0D, and then CB. So 0A, 0D, 0D, and then yeah. Now on the new versions of PyCDC, it's supported. Sadly, my version isn't updated. This is why it didn't work. But even if, like, let's say there is Python 3.14, right, and it's not supported by PyCDC yet, well, you just have to include the magic number by yourself in here, and this would work. We tried this with a friend like back in the days, and yeah, it worked actually. So this is why I remember this trick. So you could do this to make PyCDC actually even like force it to decompile new versions of Python, but make sure that it might fail. Like there is a big chance that it might fail, because in every new version of Python, the Python virtual machine will get new instructions, and this is why like the PyCDC might fail because it got unsupported instructions yet. So, but it might like decompile the instructions that it already know. So this is why you might want to use it. Use the trick, I mean. So yeah, glad, like finally I'm sharing this tricks for everyone. Okay, next challenge. It's, we solved, no. Can you, if you want to suggest me the next challenge, that would be good. Should we do more Python, or should we go for Shell Master? I will only stream for like 15 more minutes, so we need like a okay challenge like that doesn't consume that much time. Serial easy compression. I'm afraid this might take time. UPX rotations, we already solved this. I didn't solve UPX. Maybe do UPX or do the IDAT challenges, or fuck assembly, crypto, serial key. Where is serial key? I can't see anymore. Serial key. Where is serial key? Oh, serial key. I was searching for the word key. This is why I didn't find it. Okay. So one guy said crypto. One guy said maybe we will solve both of them and then close the stream. that would be it. So let's see what serial is about. Back to the repo. Let's go for crypto. Okay, let's go for crypto then. There is no problem. Crypto. Oh, Java. Okay, what should I download first, like before even opening any of the files, so like we don't cheat. Should I? Oh, it's obvious. It's very obvious. I'm just losing my mind because we streamed for about, how much did we stream for? 2 hours. Yeah, 2 hours and something. That's too much. exe file. Yeah, obviously the exe file. So you might actually want to slap me on my face because I'm downloading the exe file on the Linux machine. Okay, I know some people got Wine. Wine is just going to simulate Windows executables and execute them on Linux. But I don't use it because I got the VM, like I got the Windows VM and everything is fine for me. Beast always is a beast. Yeah, I'm just another noob. Crypto, okay. Yeah, as you could see, I can't even write. So let me download this. I'm downloading this on Linux just to run like basic analysis. Just like the best in the West. Just like the strings. Oh yeah, but turns out this is actually Java. All right, this is funny Java. Okay, you could see the PK in here, and PK is a fun thing. How often do you stream? I stream like once a week, and if I'm really bored and I don't have that much work to do, I will stream twice a week. But I think that only happened one time. But yeah, usually I just stream for like once per week, and like Monday or a Tuesday. But yeah, I was going to stream tomorrow, but I didn't stream tomorrow because it's my birthday, and I cannot stream on my birthday because I want to have some fun. So yeah. Okay. Fuck me. Okay, strings revealed that this is actually some Java compiled executable. Okay, which is fun, right? Which is really fun because I've done something even funnier right now. I've done something funnier. Okay, it's actually not an exe file. It's a zip archive, and I knew that this is a zip archive by actually running the strings. You know, happy birthday. Yeah, thank you. Thanks everyone for celebrating my birthday. Yeah, so this PK keyword is telling that this is a zip file. So when you see the PK thing, you should know that there is some zip file inside. So it might not be the file itself, but it might be inside of the file. So thank you everyone for the cool comments. Okay, so this was a zip file. You should rename this to crypto.zip. The author named it as crypto.exe just to fool people. I think even if we try to... Okay, I don't care. I'm going to execute it in here even if it's malware, because I don't care. So it's actually going to run. Let me go to downloads, run this script.exe again, because maybe it's asking for stuff. Okay, I have a Java problem. And the other actually, the author DM'd me and told me to test the challenges before actually going live. نكملوا نص الليل ونعملوا لك adminate في stream. I don't think I could do that. I'm losing energy already. So okay, so I got Java problems, but maybe on my main OS, like the problem was with the GRE, right? It's compiled with the more recent. Yeah, I need to update my GRE. GRE would take time to download. So I'm not going to actually download GRE, and yeah, I'm just going to solve it by static analysis, only doing static analysis, which might be bad. It might like involve no need to run it though, yeah. But if it's obfuscated, or if it's doing too much work, then I might want to do dynamic analysis. But yeah, okay. So let me get it on my main system. It might be flagged. It's not flagged. Cool. So there is a cool decompiler for Java. You might decompile it like online. And you might use JADX. It's called JADX. It's a Java decompiler, also like for an Android decompiler, because you know Android is mostly Java, unless it's some React Native shit. So yeah, it's not Java anymore. But yeah, it's APK is a zip archive at the end, and JADX could actually parse it, and like you know, like the APK got some architecture that JADX might help you decompress it and like analyze it in a fast and easy way. So let's get the file just from the downloads, drag and drop, and no class loaded, nothing to decompile. Very, very, very cool thing, because this was compiled Java, it's not just Java. That's not a problem. Why? Because where's my, yeah, this is my VM. No, this is not my VM. This is my VM, yeah. Because I have already unzipped the thing, okay, and it detected that there are extra bytes, and it ignored the bytes, and it just decompressed the needed thing, yes. So I could just then copy the class. Let me get the class. The class file is like the compiled Java for the GVM, because Java executes on a Java virtual machine at the end, and the class is just like one compiled class to the GVM bytecode. Like what I mean by bytecode is just machine code, because the GVM is a virtual machine, so it got its own machine code, just like my computer, like my processor got its machine code too. Okay, so we got the class. We could drag and drop again, hoping for this to work. Did it work? Yes, it worked. This is the crypto class in Java. This is the decompilation of the crypto class. Yeah, the usual fancy menu in here. Is this crypto or is it REV? You tell me. It's taking input. It's taking input. I'm like familiar with Java, but if you are not familiar with Java, then you might spend some time searching like each of the method and function names to understand like what's actually happening, to know like this is actually taking input and so on and so forth. But you could actually guess, you know, give me the flag. This should take input. That means that this line should take input. And if you are familiar with computers, you know like it's opening some scanner, which is a file descriptor, which is like. So if you are familiar with systems and familiar with some assembly and some like low-level stuff, you might also understand mostly anything that you don't know in like programming, in terms of programming and reading code. This is why assembly is actually important, and this is why like computer architecture is also important. Okay, length. Okay, then it's going to, my input is saved in the next string. It's going to take characters. So this takes the first 7 characters. This takes the second 7 characters. This takes the third 7 characters. This takes the 7 last characters from the input. Then it's going to call some function called magic, which is this guy. We are going to take a look at it. It's going to call another function. So many functions. It will concatenate the result of all of the functions, and it will do the dot equals method. This will compare a string, like the resulting string, this one, with this. It will compare this resulting string with this hash. So it might be doing some hash. It might be just be. It might just encode this in hex, you just don't know. But we see the word MD5, so it's already calculating some MD5 hash. and it's converting the hash to hex. You see the 2-hex string call. I'm literally not focusing on each line in detail because that's not how you reverse engineer like these type of challenges. You just take a look. You just throw an eye. You see some word, okay, it's just converting to hex. I don't fucking care. It just works like that. Alright, and if it's one, like it's going to add the 0, like yes, just converting to hex. So the magic is only calculating the MD5 hash of some string. The magic is called in here, so it will call the MD5 string of the flag of the input, and this function called sihr. This is how you spell it in Tunisian. It's taking some key and it's doing XOR. And it's not a problem. I just learned this like the hard way. Yeah, I failed so many times until somebody actually told me to start doing this. Because yeah, for reverse engineering, it would be good to ask people that are better than you questions and get answers. They will help you. They might give you tips. They might give you tools that you don't know, you never heard of. It would be also good to watch a pro reverse engineer do the job. So yeah, definitely needed. Alright, so magic is doing MD5. What is this doing? This is going to XOR your string with some key. Okay, this solves me the challenge. Wait, is this hex? Oh, this doesn't solve me the challenge. It's passing it to another function. What's the idea? What's the IDE? It's not an IDE, it's just a Java decompiler. It will let you debug through Java code and like compiled Java code. That's exactly why we're watching you. I'm not actually a pro reverse engineer. You might want to watch Gimvale or OA Labs. Well, I stop saying that. It's not true. You might want to watch. Yeah. Look at this live stream, for example. It's not a live stream, but
that's the thing we
yeah, it's a whole session talking about reverse engineering tips. How do you do reverse engineering in a proper way? And it just talks about the sophisticated cases. And like Gimvale talks about how he solved weird REV challenges in CTFs that he actually got no idea about, or like that are actually doing something weird or like anything. So yeah, do watch Gimvale. Actually, he is the pro reverse engineer to watch. He got actually so many live streams about reverse engineerings. I just need to scroll or maybe search. Is there that search function? Yeah, reverse engineering VM based protections, reverse engineering tips, medium hard reverse challenge, Pico CTF, VMs in anti-RE. So there are many reverse engineering challenges from this guy. So please do take a look. It's really interesting. And yeah, you might like there are so many people to watch. You really خلص فيه. والله مش يخلص فيا ما عاوني برشا كي بديت وكهو يستحق الشراوت هذوما الكل. Okay, Live Overflow got some videos about reverse engineering, so you might also want to take a look. We got I got a notification from the channel. Yeah, it's Invoke RE. Invoke RE also does reverse engineering. You might watch the Binary Ninja guys. I forgot the name though. What was the name? I forgot. I really forgot the name of the. I really forgot the name. They got another name. It's not It's not binary. Oh yeah, Victor 35. You might want to watch the Victor 35 channel. You might want to watch OA Labs reverse engineering real life malware. You might want to watch guided hacking, do some reverse engineering and game hacking. Where is reverse engineering? Reverse engineering. So he got actually this is just one playlist of many playlists, so there are many playlists, so do take a look. ماكش تعمل تطلع على الويب نص ساعة تخرج منه. maybe after my birthday. Maybe after my birthday I might like do 2 times live stream this week, because I don't think I got many stuff to do. So yeah, maybe we get into some web by the end of the week. You might also watch what is he called? I cheered OA Labs, invoke RE, CTS, or also known, I think, yeah, as I expected, I wouldn't really find the challenge. I really forgot. Flare on live stream. ما سكرتوه الفي ام تاع الويب عاد. اي فما دوكر ولدي. ما عنديش دوكر. Web challenges. Web challenges. نختار واي فاي. Yeah, we got the Docker file. We could do Docker compose up and start playing the challenge. Yeah, I like starting PHPS here. Cool. We might take a look at the web challenges. It's been a while since I actually had a web live stream, so why not? Okay, back to the crypto thing. Wait a second. I wanted to find... Oh yeah, here we go. Based God 69. You might want to watch this guy. Hello. What else? What else? I'm sure there is like people that I actually forgot about, sadly, because yeah, that's me. I don't know. I don't really know. Yeah, the Zeta2 channel. I just remembered it. Do take a look at Carl Svensson. He also does live streams, but it's been 2 years since he actually published one. Smooth web sessions. I hope. What else? I think this is what I remember mostly. You might also want to follow our friend Ironbite. So yeah, he is one of our friends. So ليه مازال بكري على الديسيت، مازالوا 3 جماعات جاوي بيه. Yeah, this is it. So yeah, Ironbite got cool videos, cool lightweight videos. Dumb question: how to understand and do CTFs? As I tried before, cybersec seems hard, honestly. Data. Is there? I know like Data Overflow is some kind of consulting laboratory. Oh, yeah. Problem solving? No, I don't know. I don't know what Data Overflow is. That. Okay. Oh, you're talking about the meme. Oh yeah, I didn't get the joke because I'm dumb. So, actually, cybersecurity might get hard when you actually start doing real business. And what I mean by real business is basically research. Basically, I feel like research is the only section that makes cybersecurity hard, actually, because you need to understand programming deeply, you need to understand reverse engineering deeply, you need to understand binary exploitation in a deep manner, you need to understand, you need to have a good knowledge in crypto, you need to have a good knowledge in forensics, and so on and so forth. So researching is the hardest part. Apart from that, cybersecurity like is easy and hard depending on what you are doing. So if you are, for example, playing a CTF, well, there exists hard CTFs, just like easy CTFs, like the friendly CTF would exist to help you get started. If you actually didn't like CTFs before, I would suggest you actually play the challenges. Where is the GitHub? So I already shared the GitHub repository. Do take a look at the challenges. If you fail, you could DM me. I might be able to help you. And yeah, you could do penetration testing as like just in the beginning of learning web exploitation and basic red teaming stuff. So you might do penetration testing, hack the box, and try hack me are good places. Low level learning is also another channel that talks about. Yeah, I forgot about low level learning. Yeah, then like when I started when I started doing stuff in the field, I actually started doing web exploitation, and I was doing it in a dumb way, just using tools back in the days like the Havish. I'm sure you remember the Havish tool. It's some SQL injection darknet. It's some SQL injection. It's some kind of a like receipt, but yeah, it's this tool that does SQL injection. So I was like using the like kind of these tools, and I was just exploiting web bugs with them in a dumb way. After that, I started learning programming. Learning programming totally helped me. I started to get interested into developing stuff and knowing how stuff actually works internally. And by doing that, you are on the good path, and you will stop being a script kiddie. So you are not using stuff that you don't understand. You are not just throwing CVs at some web server that you found in the wild. You are actually applying real stuff. So SQL is worth it to learn now. Yeah, definitely worth it to learn. Definitely worth it to learn. Like bug bounty hunters are still finding SQL injections till this day. So it's not actually like a deprecated thing. My phone is 1%. It will actually die soon, and I cannot read the chat anymore. So I need to charge this. And yes, what else? So apart from that, if you feel like web exploitation is not your thing, then you could switch and do reverse engineering and binary exploitation, cryptography, forensics, like whatever you like. You could try like these categories in CTFs, and you will get a basic idea, and you will get a feeling for each one of the categories, and then you could choose a category basically. So yeah, I actually encourage you to go and try to start your journey like the proper way. And yeah, go to local CTFs if you are Tunisian, I think. So yeah, visit local CTFs. Even if you fail, just go to play. You will encounter you will make connections that will help you through the journey, and you will actually meet people that will correct some ideas in your mind, and yeah, you are just exchanging information, and it's good for you. It's really good. I think this is the answer. Also, sometimes I feel, especially for like this field, learning stuff is not by taking courses. It's okay to watch a tutorial and like focus on reading some paper or like some article, but there is a 70% or like an 80% even progress that you do by yourself by practicing and failing, especially failing at doing the job. Yeah, it seems hard because it's like the first steps. The first steps are always hard to take, so that's not a problem. It's actually a normal feeling. Alright, let me get back to the string builder. So it XORs our input. This is our input, yeah. It XORs our input with some key, and it will pass it to the abracadabra function, which will loop and convert it to hex. Yeah, this is enough to solve the challenge. Oh, there's the flag is just there. The flag. You need to research and start easy CTFs because CTF have easier than most CTFs. So yeah, true. You just you just need to try stuff and get a feeling like, and it's okay to fail and like feel like it's hard. You just need to be consistent, and you don't have to be disappointed because that's a normal feeling, totally a normal feeling that everyone actually felt before when starting. So like because most of the people start without a mentor, so it's blind for them, it's completely blind for them. They don't know anything about this. Okay, so the last 7 characters of the flag are base64 encoded, so I'm just going to take this base64 encoded string, and I'm going to let me get Python. Okay, this is Python. So flag is some byte array. What is the length of the flag? The length of the flag, it's just 7 times 4, which is 28. 28. Spamming is not real hacking, right? Yeah, it's just phishing. But yeah, phishing is hacking at the end. Everyone got his own definition of hacking, so we could count it. So the flag is 28 bytes, 7 times 4, and we got the last 7 characters are just base64 encoded. So I'm gonna take this base64 string from base64, import me the b64. I'm being dumb. b64 decode as b this, and these are the last 7 characters of the flag. All right. So we're gonna map them to the flag. So from position 21, or like not 21, but from position 7 times 3 to the end, just copy these things. Copy these bytes. So we just copied 7 bytes to the end of the flag, alright? 28 characters. So now we need these. So we have recovered this. We need to recover this one. So the abracadabra. And by reading this, I just see that it's converting my stuff to hex. It's just converting it to hex. So I will take some hex here. Okay, how many characters I will take? 7 characters. That means I will take this whole string and separate it in Sublime Text. So 1, 2, 3, 4, 5, 6, 7. So these are 7 bytes. Okay, each 2 digits form a byte. And wait a second. These are another 7 bytes. So we just decode them from hex, bytes dot from hex. We pass in the bytes. And these are another 7 characters. We just need to map them. So 7 times 2 to the 7 times 3 equals to that. So there's a rev equals some love thing. And yeah, we are close. We just need 2 more parts and we solve the challenge. We need this sihr function, which is just XORing the key and returning it in hex. So because abracadabra is just converting the bytes to hex. So we will just take 7 bytes. Let me just take 7 bytes. 1, 2, 3, 4, 5, 6, 7. These are 7 bytes. And I need to convert them from hex. So bytes.convert from hex. And then I need to XOR them with this key, with this part of the key. Because you know, the inverse of an XOR is just an XOR. Okay? Because XOR will just flip the bits. So we just flip them again and get the initial result. Okay, so I'm actually lazy to XOR stuff using a loop or like using that one-liner using the zip. So I'm going to do from pwn import XOR The pawn tools that we use in binary exploitation actually got an XOR function that I use because I'm too lazy, so yeah. Okay, I made a mistake here. The key is only, yeah, it's 2 Ys. Okay, so we XOR them. I fucked up something. Let me take 7 characters from here. Yeah, this is it. Okay, because like this, the key is longer, like in the length, it's longer than the input. That means it actually added more garbage data that we don't need. So we only need 7 bytes because it's splitting the flag into 7 bytes, into chunks of 7. So let me get this part into the 7 times 1 to the 7 times 2, and we are just missing the flag format. This is Securinets, it's too obvious, and this is the MD5. This is the MD5 for it, you know. The magic thing is just calculating the MD5. Alright, so we could just take this MD5. We could maybe Google it. Maybe it's already cracked. We might use like some. I don't think it's in the crack station or like in any other hash killer website for MD5. It's actually very rare to have this, but I'm gonna try. Oh, it's there actually. Okay, I'm surprised. And yeah, flag from 0 to 7 is just this part. And we got the full flag now. Securinets crypto plus rev equals love. So this is the flag. Okay, I'm going to. He made another suggestions for. He told me to solve the serial key challenge. I'm gonna take a look. If it's going to take like more than 10 minutes, then yeah, I'm just not going to solve it. I'm going to solve it on another live stream. Let me see. So reverse serial key. Oh, you got the Linux and like Windows version. That's so good actually. Serial key. Let's download this. Okay. Oh, these are funny numbers, but the key seems to be longer actually. So here is your flag. It will show the key, which might be taken from my input. I'm already tired. I'm already tired. So also I need to fix my trace because it's not doing anything. I really hate this. Let me try to open this in IDA quickly. So where is my? Let me get it here. Yeah, just save it there. Hello, serial key. Copy it. Get it into my not the Windows Store. Here, this one. Put it. Throw it into IDA. Take a look at the. Why is that so good? Because it feels like it's probably parts of the serial key. You know, you don't usually see these numbers when running strings. When you run strings too many times, you actually know what strings that always exist and what are the strings that does not exist always. So you know what's interesting and what's not. Alright, the main function. Okay. Okay, sadly I remember this challenge because this challenge was I helped somebody to actually solve the challenge, so I know the challenge. I already know this challenge. Okay, so should we do it? Yeah, let's do it. 24 people are watching, so why not? So enter a valid serial key. It will take input. It will loop on the input, and it's not doing anything, alright? It's just looping on the input, and then it's using the I in like if statements and stuff. So it's basically calculating the size of your input. So once it will encounter a null byte, it will quit once like a null byte is encountered. So like the string is terminated, and on each loop on like the characters, it will actually add a +1 to the size. So then we got the V8 initialized to 0, V12 is equal to 1. Okay, this seems like the conditions, yeah. And it's reading into the S1 variable. Now, what is this first loop doing, like this part doing? So this part here is looping on the input. It's looping on the input. V8 is the iterator. It's looping on it. And each time V8, like V8 and 1, will basically get you the least significant bit, alright? And, you know, in binary format, for example, let me give you some numbers, like 4, 3, and 2. So 4 is just 100, 3 is just 1, 2 is just 10, alright? So this for thing is actually the end one thing will return the last bit, like the last bit in here, and the last bit will tell you if the number is actually odd or even. So if the last digit is 1, your number is actually odd. If it's 0, the number is even. Okay, so if V8 and 1 is not equal to 0, that means that it will enter the if block when the V8 is not equal to 0. That means V8 is odd. So V8 is equal to V8 and 1 is equal to 1. So this will work on odd positions, okay? And for example, if you got like A, B, C, D, so 0 is not an odd position, it's an even position, but B is an odd position, and it will take the number. Okay, yes, this -48 is just a -0, and this will convert a number to, like, for example, because 1 is not equal to 1 as an integer, it's equal to 0x38. We are playing with its hex, like decimal representation, so we need to make it an integer. This is why we subtract 0 from it, because 0 is just 0x30. So when you subtract 31 from 30, you will actually get 1, which is the integer, like the real value there. The real integer in that position. So this is our integer. Mod 2, it's not equal to 1. It will do that. So the mod 2 is also checking for the parity. So if we are in an odd position, it will break when the number there is not odd. When the number is not odd, break. That means in all the odd positions in my input, I need to have odd numbers, and this also means that the input would only contain numbers. All right. So yeah, this is funny. The same thing is applied here. So else if the position is not equal to 0, it will break. Like if you are not on an odd position, you are on an even position. And if you are on an even position, the number there need to be even. So if it's not equal to 0, like ending it with a 1, or mod 2, if it's not equal to 0, it will break. That means on odd positions, you need to have odd numbers, and on even positions, you need to have even numbers. So let's actually take some notes. So odd position, odd digit, odd even position will need an even digit. So like this could have a 1, 3, 5, 7, and 9. This will have a 0, 2, 4, 6, and 8, right? Next loop. So let me see. So this is the next loop. The next loop is looping on the input. It's converting like the digits on the positions to just real integers, and it's adding them like from some position. It's taking the G, it's taking the G plus 1, like the digit after the current one, and it's taking the digit after the current one. Like if we have 1, 2, 3, G is pointing here, it will take the 1, the 2, and 3. So it will read all of this and it will add them together. That means it will make 1 plus 2 plus 3. So it will just add the numbers together, and it's comparing them to the okay, this is funny. So if the sum of the first 3 numbers is smaller than the sum of the second 3 numbers, so let's say you got this number 1, 2, 3, 4, 5, 6. All right, so 4 plus 5. I know this doesn't meet the first condition, I'm just using it to explain stuff. So if this number is smaller than this number, like the sum of them, it will break. So it's not a correct key. All right, that means that each pair of 3 numbers needs, like, the sum of its digits needs to be bigger than the one next to it. All right, then we have some, okay, let me also note this one. So we have this, we have every pair of 3 numbers, like every pair of 3 numbers when summed need to be bigger than the sum of 3 numbers next to it, basically. All right, then what? Then there's another loop, actually. This loop here. Okay, this is a bug in the tool. This loop will loop on the whole input, and it will add the numbers, like make the sum of all of the digits, because the input is just digits. It will sum all the digits of my input, and it will store them in the v15. Then v15 is compared to 134. Okay, so sum of all digits is equal to needs to be equal to 134. Right, this is another condition. Next we have this comparisons. This compares the start of my input with these 5 numbers. That means that my input should start with this 5 numbers. Start of input, or like of key. This is like we are trying to crack a program. Then if this works, if this is correct, it will try and compare size minus 5. All right, it's comparing the last 5 digits. So we also get the last 5 digits of the serial key. Last of key is this. What more conditions do we got? There is another loop making sure. So if it encounters a 0, it will quit. Okay. It will set v17 to 0. That means it's false, and it will quit. That means that we should not have zeros in our no zeros in our serial key, basically. Okay. Pointers everywhere. Okay. Then we got something else. It's taking the 9th, 10th, and 11th digits, storing them in the end pointer, converting it to some integer. That means that it will take 3 consecutive digits and convert it to input. So if we got like 1, 2, 3, it will just convert this from string to an integer equal to 1, 2, 3. And then it will calculate the square root of that number. It needs to be equal to 27. That means that 9 from like input on from 9 to 11, it needs to be equal to wait a second. So it needs to be equal to the 27 to the power of 2, because it's doing square root on the 3 numbers to get 27. So we just take the 27 to the power of 2. We will get the 3. So 27 to the power of 2 is just 729. So we will save this condition. then we have, what do we have? The 6, 7, 8 position. This task, the 6, 7, 8 positions are, okay, need to be equal to 6, 9, and 8. So 6, 7, and 8 input 6 to 8 needs to be equal to 6, 9, 8. Now we have, okay, there are actually more comparisons in here, but there is a little problem. If you click on the V23, it's actually not referenced anywhere, but it's defined in here. Alright, that means that IDA failed to get the real size of the S1 variable, and this is why it like created 3 separate variables in memory. So we need to patch the size for it. I will make it. I need to get the size of the full key at first. So how do I actually know the size of the full key? Well. How do I actually know this? Oh, you see, size equal to 24. So we know that there are 24 digits plus the null byte at the end that will terminate the string. It makes it 25 bytes. So 25 bytes there, yes, and we have a clean S1 right now. You see, this line is corrected, and we got like the real positions now. So I could just take the S1. I will take this line actually. I'm too lazy. This line is doing simple stuff. It's comparing, let's not care about the before equal part. It's taking the 13th position, -1, it needs to be equal to the digit on the 12th position, and it's doing the same thing with the 14th, 13, 15 and 14th position again. So they are just conditions, alright? So now at this stage, we actually know we know parts of the key, but there are parts that we don't know, and that we cannot guess because sadly, many conditions might satisfy this, like more than one condition, alright? So what are we actually going to do to make things clear and fast? Basically, we are going to use something called SMT solver, and you could Google about it. You could learn more about SMT solvers. It's satisfiability modulo theories. Basically, you give it so many theories or like constraints, and it will try to satisfy the right input, like get the right input, which is S1, in order to satisfy all of the conditions there. So title conditions with chat. Yeah, I don't like the idea. Okay, so we just need to throw the SMT solver, like all the theories, all the constraints that we gathered, and it should generate us a correct value of S1 that should satisfy all of these conditions. Just need consecutive letters to be equal to by 2, I guess. Yeah, maybe at the end this is what should happen. But I like the first reflex I would get when playing this challenge is to just throw stuff to Z3. Wasim is a king. Yeah, he's so good. Okay, consecutive increasing sequence. So you either know the shit, or try to solve the puzzle, or throw it into some satisfiability modulo theories. And I will choose to throw it there because I'm very tired and I cannot, and I'm too lazy to think, like to try and solve the puzzle myself. So there is Z3, definitely not the BMW. It's a Python module for theorem prover. It's an SMT solver. So I already got it installed. You can install it using pip3 install Z3 solver, and it should get installed. I already got the Z3 here. So we're gonna make a solver script. So yes, solver.py. Let me import the Z3, and let's initialize the solver class. So we will put all of the constraints in there. So I will copy this, put it in a very large comment just to keep it next to me. Now I need to define the S1, like make it a variable for the Z3 to solve. All right. So S1 is going to be an array of bit vectors that are just flag of something. This is the name of the name of the vector, the name of the variable I meant, and it's going to be an 8-bit vector. And you could imagine vectors as simple arrays. So it's just an array of bits, an array of 8 bits, and that's just 1 byte, right? Because 8 bits are just 1 byte, and every character of the input is just 1 byte. So okay, for I in range 24, because we know that we got 24 digits to solve for, and then we could start throwing conditions to Z3. So s.add. So first of all, we need to satisfy the odd position needs an odd digit comparison. This is not hard. You could just also there's an even like another thing that you need to do at the beginning, which is to tell Z3 that all of the things I'm trying to do are just digits. Okay, you could also use like the int here. You could like make them all integers. That's also possible. You could use the bit vector. It's up to you. So for character in S1, I will add the character, make it there's a little problem. Wait a second. 9. Yeah, that's a little problem. I could use it as a bitvec again, or I could just switch to int. That's not a problem. The only thing, خلينا نشوفوا scripting skills. خلوا GPT. Okay. Like it's between 1 and 9. It can't be a 0. No zeros in our serial key. So we already satisfied this condition. Now we need to make another loop. I could like add stuff in that same loop, but let's separate them just so you could understand and get a better view of what's happening. Then we have now I'm going to satisfy the odd position condition, and I'm going to do C. Okay, so if I'm going to loop on the range of this, so like I get the index, let me make this I. So this is the index of the current digit, and if the index of the current digit is actually odd, so if it's odd, then I'm gonna say C should be, S1 of I should be odd. So mod 2 is different than 0. So it's an odd digit. Otherwise, if it's even, then yeah, it's even. It needs to be equal to 0. There is no problem. Right. This will map every odd position and make the digit odd, and every even position and make its digit even. So we have satisfied both of these conditions. Now we need to, every pair of 3 numbers when summed needs to be bigger than the sum of 3 numbers next to it. Okay, so we're gonna loop on this thing. So I could actually loop in the same way, just like he looped. He looped in this way, starting from 0, advancing by 3, and subtracting 5 from the size of the input. So this is what I will do. Start from 0, length of the S1 minus 5, and step by 3. And then I'm gonna add the condition that every 3 numbers, when added together, need to be bigger than the ones next to them. So I plus 3 I plus 4, and then I plus 5. So yeah, this is the condition. We have satisfied this condition. There's no problem. Let me set the numbers. Then the sum of all of the characters of the input need to be equal to 135. So I could make like a sum variable in here that is, I would call it like sum in this way is equal to 0, sum plus equal to the current C, and then you could say the sum needs to be equal to 134. This way you could calculate the sum. فما بلوس ناقصة. Yes, فما بلوس ناقصة في الوحدة 30. لحظة برك. Okay. Merci. Okay, now we have actually satisfied this condition too. The start of the key, the starting of the key needs to be equal to 89898. So this is the start of the key. So s.add s1 of 0 equals that. My bad. Okay, this is the start of the key. I'm going to just increment the indexes. So start of the key. Last of the key needs to be equal to this number. So I'm just gonna do that, do this, do this. S.add s of 1. We could do like the size minus 5 just like he did. Or we could just like calculate it ourselves, like 24 minus 5 will be just 19, so we could just calculate it from the 19th position, basically. So 19 is equal. Did I remove a digit? I think I fucking removed a digit. Oh yeah, that was 1. 19 is equal to 1. It's... fuck me. But yeah, it's 12125, so it's... we need to remove this. It's 12125, basically, so... then we need to tell it that these are 20, 21, 22, and 23. Alright. Then what? Vim Helna, Mousepad Gang, Gymnastics. Bro uses Vim better than I use. Okay, then what? Then we have positions from 9 to 11. Let me copy this too because I'm too lazy to get back to it. So need to remove this, and it's just it's just 9, 10, 11. So S1, 9, 10, and 11. I just hate it when I'm actually too tired and I'm typing on the keyboard. I start to type nonsense. So, and this starts from, I remember 14th position. No, it's not 14th. Maybe it's 10th position. Because I remember there is some conditions for the 14th number, so I just should be wrong. Oh, I'm super tired. Okay, let me see. It's 9, 10, 11, and 6, 7, and 8. So this is actually 6, 7, 8, and this is actually 9, 10, and 11. So we got these positions. We still have one condition. We just got one condition. Play me like you play that way. Okay, the final condition is this condition actually. It's just one condition, which is this comparison. I'm just gonna copy it. I'm gonna put it here, and I'm going to take this line, escape the ends with a new line. Okay, that doesn't work. Fuck. I will escape the ends with let's fucking put a parenthesis there, and then I'm going to do it myself because yeah, fuck them. Sometimes it actually doesn't do the job. And let's add the s.add thing. So yeah, we got all of the conditions. Let's see if there is some check, if like there is some satisfying input. if like Z3 found some satisfying input, we could run the solver. It told us that it's unsatisfied because I typed something wrong. Well, I think I know what is going wrong. Yeah, probably these positions. Probably this. Maybe. I might be wrong though. Don't listen to me. I'm saying nonsense. What is wrong with my solver? Okay. Let me just get this back. Okay, the solver. Did I put some wrong index here? No. The sum is correct. The characters are correct there. I'm not really sure what's wrong. Okay, let me try. Maybe it wants this as integer instead of bit vectors. Even though bit vectors work, I don't think this will solve the problem. We got a donation. Thank you for the great live stream. This is like the third time you do a donation, so I'm so thankful. I'm really thankful for you. Yeah, thanks again for the donation. That actually means a lot. So let's see if S1 is. Let's see if int solves the problem. Int doesn't solve the problem. Please give me my bitvic back. I made something dumb in one of the conditions basically. So if the position is odd, mod 2 it's not 0. Otherwise it should be equal to 0. This looks fine. S1 of I. This also looks fine to me. The sum, then there is maybe it's in this part. Then let me try to remove this like part. Let's see. Yeah, there is a satisfied condition, but it doesn't mean that this part is actually wrong. You never know. Let me just take a look in here. So it's 12125. It's 729. Let me open IDA real quickly. It's 729 in this, which is just 9 10 11. Yeah, it's 9 10 11. So we are correct, and there is a 698. 6 and actually solve. Good challenges, bro. As beginner, just let me do some research. Yeah, the challenges are actually very good for like beginner friendly. For beginners, basically. They will force you to teach something. So yeah, good job for all the Securinets team for actually organizing the 4 days or 5 days event, I think. Oh, I opened Discord by mistake. So we have 698, 698, 698, 698, 678. Oh, go fuck yourself. 678. Oh, I'm lost. I'm really lost. 678 is this guy, and it's 698. 678 is 698. This is correct. 13 minus 1 is 12. 14 minus 1 is 13. And 15, yeah, this is, all of this is correct. The only place I might have made a mistake on is, oh, I forgot the 0 thing. I forgot to say, oh no, I put it in here. I made a really huge mistake. This is like strictly bigger than 0 and not strictly bigger than 1. That was really dumb. Oh, nobody actually told me about this mistake. How do I leave oh my ZSH as the default in the terminal, so whenever I open the terminal it opens with oh my ZSH? Does anyone know? I think it's already in the repo. I was using oh my ZSH on my Ubuntu system. Or you could probably edit the .zshrc file. I really forgot, sadly. I'm sorry. I probably cannot help with this. It's been a while since I really used it. But I remember also, like in the installation, it will actually ask if you want to make the oh my ZSH your default terminal configuration. Maybe I'm wrong. I'm not sure. Sorry for not helping with this. Actually, didn't use it in a long while. Okay, solver works. We got a satisfied condition. We just need to dump the model. So let me show you the model real quickly. S.model. Print the model. Print the model. This is the model. These are the digits. However, these are like they are not ordered, so I need to order them. How do I order them? It's going to be a for I in range. Or like for character in the M, basically S1 over C, because you know the C at the end is just the flag object, which we defined in the S1 as a bit vector. It's just the bit vec object. So we could do the S1 over C to get the value from the model. Wait, sorry, this is not for C and M, it's for C and S1. So we loop on the bit vectors and we get them from the model. So this is M of C. All right, this is the correct one. Then you could print them in a one line, or you could do a flag equal empty string flag plus equal the character. This doesn't need to be a character, you just need to take it as a string. So as string. This will convert the bit vector to a string. Print me the flag. Execute the solver. This is what we get. Execute the serial key program. Do this. And yeah, here is the correct flag. Here's your flag. We got the flag. So yeah, I'm feeling dead after doing this live stream. It's been 3 hours and about 30 minutes. So thank you everyone for actually joining me through the stream and for sticking to the end. Thank you also for all of your donations. We could reread the messages quickly before closing the live stream. So like if I just if I made mistakes and didn't mention any of you. So yeah, keep going. She had these 3 times and we got Ali. Oh no, Bakshish is not even supporting the Unicode 8, like the E thingy. I don't know what to call it in English. وقت ايش اللايف ستريم الجاي؟ والله ما نعرف. Life is hard. Easy is even harder. Happy tomorrow birthday again. Thank you, bro. Thank you so much. We could get the phone back and read the messages. Much love, happy birthday. Thank you so much, Ryan. Glad you joined us in the stream and you enjoyed the content. Much love, Abid. Thank you everyone for the cool messages. We get in a birthday stream. It's a special day. I want to have fun with my friends, so it's hard. It's hard to get a stream on my birthday. Eid Saeed, ya bro. Thank you, Ziyad. And what else? So yeah, I think we just came to an end. Yeah, I remember that I also failed the assembly challenge. Where's the assembly challenge? Oh, the GitHub repo is here. I failed the assembly challenge because I made a stupid mistake, just like I made one in here. Yeah, we might get back to it on the next live stream. I might do a stream where like I play Rev and Web and Pound like together. So I don't know if it's a cool idea or not, but yeah, thinking about it. If you got me ideas for like live streams, you could actually send me a message on Facebook or like Discord, and I would be thankful. I'm actually open for any cool ideas, creative ideas. So do DM me. I will answer once I'm free. And yeah, we gave you reverse engineering resources in the middle of the stream, so there is nothing else to do. Let's see. Let's take a look at CTF time real quickly, because I know I'm not going to open the computer before, like after closing the live stream. Upcoming events. Okay. Oh, we got the Accelerate. This is a cool event. I think they got a live stream. I'm not sure. It's a Google event. What about solving quals tasks? Yeah, that's a good idea. That's actually a really good idea that I thought about. It's actually a good idea. I know they are like advanced challenges, but yeah, maybe there are like maybe there are viewers that enjoy very advanced content or like advanced content. Most of the late live streams I'm doing are just for beginners, so yeah, maybe we need to level up. Tell us about TempleOS. TempleOS is okay. I will talk a little bit about TempleOS. The challenge is made for the memes, alright? The challenge is just made for the memes. I'm not going to lie. I could have used like another graphics library to represent my stuff instead of actually using TempleOS and creating a whole game. But I actually chose TempleOS for the memes. And I mean, there like it didn't really make like the challenge harder or anything. But yeah, this is TempleOS. If you don't know TempleOS, please Google about it, and you might also want to watch YouTube videos about TempleOS. Why not participate in this kind of CTFs? Is it a matter of energy? Accelerate. I think it's only a local CTFs, also with qualifications from the Google CTF that happened already, I think. So yeah, I didn't play in the. I actually played alone in the Google CTF, like at the qualifiers of last year, and yeah, I just played for fun. I solved like 2-3 web challenges, I think, and yeah, I just didn't touch it again. So yeah, TempleOS is just an operating system that was created by Terry Davis. If you don't know Terry Davis, you might want to read about him. He's actually a computer enthusiast. He got an engineering degree in electrical engineering, I think. He's dead, so yeah, rest in peace, Terry Davis. He made the TempleOS by himself, alone. So one person created a whole operating system. It's actually like a simple OS. It got no networking and stuff. But let me tell you something. This guy made a whole programming language. And he made a whole, he made the whole operating system using the created programming language that he made. And he made a compiler for the programming language, and like, it's actually so hard. It even got its own assembly. And the assembly of TempleOS is actually very similar to the x86 and x64 assembly, but they are not the same. And I actually discovered this when creating the challenge. Yes, true. That's true. Point challenges for quals hold many cool concepts. Yeah, the programming language is called Holy C. It's just a Holy C. It's just C, but it's holy. You could see it here. Yeah, you see this, like, I don't know what to call it. It's the Holy C. It's the syntax of Holy C is very similar to. That's not what I want. There's actually a cheat sheet for like documenting the Holy C programming language, and it's actually very similar to. Let me get a basic function. Like this function does addition. This is the return type integer 64. That means like an unsigned long in C, because 64 bits are 8 bytes. It's a long integer. Takes two long integers, adds them, and returns. So it's pretty similar to the C syntax, but slightly different in terms of types and also some syntax. I remember a command that lets you talk to Jesus in TempleOS. Yes, I forgot the command. Let me just. I think if I do Alt A, I think. This is the help menu. And if I go and talk, I think it's some F actually. Talk. Is there a talk thing? Task, no, talk. Talk. I was writing this. No. Doesn't it? Oh, talk. Shit, talk. Where's the semicolon? It's here. No, I made a mistake. Talk. It's not how it works. Let's start. Talk, TempleOS. I remember command. Yeah. I'm trying to execute it. I didn't execute it before. You can also download the Nobody Solved the Challenge. Actually, it's 0 solves, and everyone is hating on me because I created the heavy reverse engineering challenge. But anyways, also there's the Zeal OS, which is a fork from the TempleOS, and it actually got networking support. So it's a cool OS. I was trying to execute that. For the God Wars, you just press F7 in the terminal. It will post, okay, just F7. Removed, instructed, remitist, government, war, license. So you see, we got 2 words. And this like words thing, this like just saying, but Terry Davis said that this is like God talking to us, and these words actually will tell us about something in the future. So there's government and war, so we are expecting a third worldwide war. And it's actually a cool OS. It even got games in it. I could try and play. Where's my mouse? Play نجمش نلعب التشالنج متاع سبارك بليز. And I thought the web task was hard. It's actually not a hard challenge. It just takes time. That's it. Let's open one game. Let's see. I actually enjoy this game. Also, my challenge is inspired from this game. So this game is about killing. It's an FPS game without a mouse. And I'm bad at this. So you kill these monsters by hitting space and firing on them, and this is like all what the OS is about. Then you complete the game and you need to make a best score in time. It got so many other games, so maybe you want to try it yourself. Anyways, so this is my challenge. If you run the dear comment, the challenge is called Fourth Temple. So this is the source code for my challenge. Also, a huge part of the source code a huge parts of nice aim. I got bad aim. So a huge part of the source code is not needed. Whoops. Let me execute my challenge is this challenge. So you got this cube. The idea behind my challenge. So you got this cube in the map, and each face of the cube is just a character of the flag, like drawn on the cube. It's drawn on the cube. For example, like let's say there is the character S in here, and there is the E in here, and so on and so forth. And then I just encoded the pixels of the characters, and this is the result after the encoding. So the character is no more visible, alright? And you have another yellow cube on here, and using the keyboard, just pressing stuff on my keyboard, I can actually draw stuff on this yellow cube. For example, if I do Ctrl X, I will draw a pixel. If I do Ctrl U, I will get to the next position, draw another pixel. Ctrl H will get up. Ctrl X will draw the pixel, and so on and so forth. You could change the color using Ctrl V, Ctrl X, Ctrl U, Ctrl X, and you could just draw stuff in here. And you could change the face of the cube using Ctrl O. So there are many shortcuts to play the game. And Firecrackers get a cut Facebook. Okay, so yeah, this is the funny thing in my challenge. This is the funny thing in my challenge. The whole logic is just in this function called the secret corner of the temple. This secret corner of the temple is just going to like initialize the draw it. This is just going to draw stuff on the screen and like repaint and revalidate the screen and refresh the rate and everything. So and then there is this thing that will get key, and this gets what you type on the keyboard, and then it will match what it gets into some numbers. So each of these numbers actually represents what you type on the keyboard, and you could get the keyboards by being smart. You could actually do it from the TempleOS too. You could hover on the function, you could do Alt A, this will open the help menu. There is the function in here, you could click on it and it will give you the source code of the getKey function. This is the source code, and the type of the thing it gets is it will, what it returns actually, sorry, it returns a ch, which is, wait a second, my bad, they are defined. I just need to find the definition. rating باش يولي 3. يبدي حتى عم جاي كي نقولوا لازم نكتب. يجاوبكم بيه يا ودي والله جاوبكم بيه. You just need to find the characters. For example, you could see here it's comparing some stuff with the ch backspace. So this is a definition of one character. You could click on here again to jump to the part of the code. So you could click on here, and this will give you the definition of all the key codes. So Control A is 0x1, Control B is 0x2, Control C is 3, and so on and so forth. All right. So yeah, so this is Control A. Control A will execute this part of the code. You know, Control B is going to execute this part of code, and I just coded them in assembly. All right. So, and there is another idea that I actually inspired from something called the data flow machine. It's not a virtual machine, it's just called data flow machine. This machine will take two things. It will take a number, and it will take an operator, like the plus, for example. This is not XOR, this is plus. And this operator will make it jump somewhere else in the code, get another number, get the next operator, and like execute this two numbers with this operator. So it's like just a data flow machine. It just like makes treatment on data, and it uses like a very fine grain like operations, right? So I just inspired it from the data flow machine, and each of the keyboard feeling them. Bro is him. Bro coded them in assembly. So yeah, it's just manipulating the yellow cube in assembly basically. And you got like the index 3, which will switch the faces. You got the index 2, which is for, is it for the columns? I think I forgot. No, wait. Index 3 is going to, I really forgot my challenge. It's been a lot since I have actually played this. Like, take a look at this. But yeah, it's just doing so many operations. What you have to do is, you could actually try to extract the whole EC file into like your Windows system or your main system. You could try then to decompile them into a higher level code, just like Python, for example, because at the end of the day, it's just a virtual machine executing code based on based on your input. And I gave to the players another thing. Let me just take a look there. Securinets calls, reverse engineering, fourth sample. So you got the opcodes CC0. This is a huge file, so I'm just gonna print like 100 lines from it. So these are just the operations, or like what I have typed on the keyboard in order to encode the matrix cube, like the flag cube. And you just need to map the keys. Like you map the keys, for example, this is Control A, it's doing some packing, alright? You You create a class VM in Python, and you create the methods based on the keys, on the key inputs and everything. And then you just take the opcodes that I gave and you map them back with your class. And this way you will see what I have exactly executed to encode the flag cube. Any idea about Exodia by Iron Byte? Actually, no, I haven't tried the challenge. I just know it's a game. It's just another game. So yeah, and then you will find out that some operations are just obfuscated for it. It's not really obfuscated, but if you are familiar with assembly, it's actually easy. For example, this 0x03, you will see it's doing multiplication with a pixel. So RG is the matrix of pixels, and it will do RG index multiplied by that 0xAAAA whatever b. This is just doing division by 3. Alright, it's just dividing by 3. That's all it's doing. Why bro is using TempleOS? For fun. For the memes. Just for the memes. And yeah, this is division by 5 and this is division by 6. If you have reverse engineered division before, you know that in assembly division happens through multiplications, not always through shifting, because sometimes you have some odd cases and you need to do multiplication in order to get the remainder and the quotient and everything. 6 is I forgot what it's doing. This is doing no, it's not comparing. Yeah, this is comparing the two cubes. Like after you draw on the yellow cube, you could compare the two cubes to see if you are correct or not. Of course, this is impossible. You're not going to do 32 by 32 pixels by your hand. So, definitely not. Then you got the 0x07. I forgot what this is doing. This seems to do XOR of the current pixel with the pixel next to it. So yeah, this is all what it's doing. Oh no, RG are just my registers. Sorry, it's not the cube matrix. It's the registers. This does a rotation with the current register, like the current register and the register next to it. You just like define them in Python, get a higher level overview of them, and then like try to trace the code. By tracing the code and like having a view of the memory next to you and everything, you will see that some operations were obfuscated. For example, I actually had no multiplication in my not this one, sorry. I actually had no multiplication in my VM virtual machine, and so I implemented multiplication using a sequence of shifts. I just did additions and shifts, I think. Yeah, and shifts. So you would just need to deobfuscate these operations. You will know it's multiplication, and you will start to get a feeling of how the pixels are being encoded, and then you just need to write a decoder to decode the matrix to the real to the flag characters, basically. So yeah. Okay. Oh shit. Okay. This was my TempleOS challenge, actually. Yeah, I just made it with TempleOS for the memes. That's it. Please don't hate on me. I actually enjoyed doing the challenge. So, yeah. And yeah. If we got any questions, for fun, even movies fear to use this as clickbait. Guys, please stop saying this stuff to me. Bro implemented multiplication. It's just inspired from some data flow machine. It was a DEF CON finals channels challenge that was sent to me by a teammate, and I just took a look at the challenge. I liked the idea, and so I implemented something similar, but in TempleOS. I hate PHP. مانيش حكى عليه. I hate PHP. How can I start learning binary notation and reverse engineering? Any advices? You could start doing them. Well, it's actually two separate things. For reverse engineering, mainly What was the drama with the French team? It's not a drama with the French team, actually. We just pinged the French team to get. We just wanted to get their. How do you say it? Shit. We just wanted to discuss something with them. So like if they are interested or not. That's it. They didn't cheat, and there is actually no drama. So I just but yeah, CTF players like drama, so they made that drama. But yeah, it's not drama. Okay, yeah. How do you start reverse engineering? You start reverse engineering by actually. There are actually many people that have talked about it, and they actually got a better answer. Okay, this is not what I wanted. They got better answer. Just a second. I think the RE tips first live stream. I'm really tired. The RE tips first live stream. I think this one talked a little bit on how to get into reverse engineering. So you might.
I recall some
Hamim left.
stories where
You
the
might
hosting
want to actually
providers,
take a look at this. I will send it, and you could also take a look at Live Overflow video. I sent this before in the chat, but I'm going to resend it. It's talking about. It's there. It's the video is just telling you what I'm going to tell you, but in a better way, because you know it's a video, so it's scripted and everything. So make sure to watch it. But I will answer it for sure. Where is the? Okay, we are fucked. I'm starting to lose my mind. Anyways, so this is a way to learn reverse engineering. You just start learning some assembly and some C programming, like the basic low-level programming language. Then you could start writing C programs. You compile them, and then you take a look at the assembly version that was outputted. And this way, you could actually match between the assembly code and the C code, and you would start learning assembly for reverse engineering. And then you could actually start doing challenges. You could actually do Pound College challenges because they are actually really, really easy and beginner friendly. So do take a look. You could also try the. ما زلت نص ساعة صح ويجي نص الليل. عمل علينا تلا في الفوات. والله نعمل تلا إن شاء الله. Pound College. You could also play Pico CTF challenges because yeah, they are just the most basic challenges. So yeah, do make sure to take a look at Pico CTF. There is also a little of advanced advanced platforms like the reversing.kr. This is actually not a little advanced, but you need to have basic knowledge in reverse engineering to start playing on this website. Then you got the dreamhack.io. It's a classic. It got all of the categories. You get all the categories. Just a second. Wargame CTF community. You just go to CTF. By the way, is there a CTF soon? I'm really bored. Dreamhack. I forgot how to use the website. Is this already? Oh, this is on December. Right. I think the closest CTF is on. Oh, there is one on November. Okay, this is cool. But I can't play, sadly. Okay, this is this collides with my exams, and yeah. Oh, there is one in October. Maybe we play. So yeah, this website actually you could go to the war game, you could choose reverse engineering, and you get like baby challenges, and then the difficulty increases. And the baby challenges are really really easy. And when you encounter one of these challenges, you especially as a beginner, from a beginner perspective, you would need to make so much research about what you are doing, like your tooling, maybe the environment you're in, I don't know, the different instructions you encounter. There are so many things to research as a beginner, and the challenges are variant and they are different and they are easy. So it's very good to actually let you how do you say it? Investigate as much information as you could. Viewer count going up, back again. Going back again because I don't know why. Let's see, how many subs do we get? We got 531, 48 likes. I could draw a graph on my live stream. So this is it. You make a binary exploitation live stream. It's like let me draw it. So when we make a binary exploitation live stream, it's actually here. This is the view count, right? These are the live streams. Okay, so we make a binary exploitation live stream. The views count is actually high. We make a web live stream. This is the views count, and sometimes it's even here. You do web. Okay, when you do REV, it's actually in the middle. It's just in here. You do pound again, it gets back up, and so on and so forth. This is how my live streams views count work. Okay, what else could you do? Because reverse engineering is a skill, it's like you will acquire it by actually you could actually just acquire it by playing so many challenges and reverse engineering so many things in real life. And yeah, RootMe is also a good resource, so you might want to try RootMe too. And ويبجاو الساعة يلا غالبا ما العبيد ما معلش عليها. Anyways, binary exploitation is like the same path, kind of, because they are both low level. So yeah, this is it. I think I want to close the stream right now. I'm actually feeling really tired. I know it's only 30 minutes for my birthday to come, but I don't know. I'm just really tired. I need to eat. I didn't have dinner, so thank you everyone for being present. Thanks for saying the happy birthday message. And yeah, thanks to all the moderators for managing the live stream with me and for keeping the chat alive. So yeah, thanks everyone again. I had fun on this one, even though the views count was actually lower. Yeah, good night and see you on the next one. I will share on my Facebook as usual. So yeah, just good night everyone.